results because your gravitational potential you're following, which is a curve.
Frame.
Gravitational
Horizontal
potential. Gravitational potential is what you're following with that.
Right, so gravitational equipotential is what curves the horizontal. I did say this earlier, didn't I?
That's what your water level's following. It doesn't
making
gravitational equipotential
bend a straight line. Fantastic.
You are following gravitational equipotential with the surfaces of those water. They will follow the same height from the center of the Earth. They will follow gravitational equipotential. They will equalize. PE was mg delta H across the entire system. You would see the same results on a flat Earth and the globe. This is your problem.
Your results. I don't have a problem. Straight lines are straight for me. I don't have any problems.
The problem for your test is that it doesn't differentiate. I congratulate you for attempting to do an experiment test, whatever you want to call it. The problem is you don't have a differentiating factor between the two things you're testing.
3 different water levels there.
No. Differentiating factor is the difference in results expected. You cannot say, with reference to the surfaces of those water,
I have to
tell me
different results, do I?
Yeah. To prove one thing, you have
to. Can I not just do it and then see what happens? Is that not how it works?
You're trying to differentiate between the globe and flat Earth, whatever you want to call it.
I'm just showing there's a test that I think can show a difference between a curve and a straight line.
You need to say what you think that difference is.
No, it's fine. Fine. You don't know.
You cannot state a difference in your test between the expected results. This is your problem. If you cannot state that difference, your test is void.
Why do we need to have expected results?
Stop
what are you talking about? Why can we not just do the test and see what we see?
Based on expected. You go, I think this will happen, and then you test
the curve.
What you do is you go, I think this will happen if I do this. I'm going to test it. The problem is you have no expected results. The results you're going to see would be the same on a flat Earth and a globe. You cannot differentiate these results.
You can't differentiate. I've set a test up.
Because I said they're not different. The results aren't different. You need to explain to me how the expected results are different with reference to those surfaces of the water. No.
It's horizontal.
With reference to the surfaces of the water in those tubes, what are the expected differences? You've got nothing.
Okay, right. So
you don't prove anything either way.
Let's start at one end of the canal, right? And then 2 miles away, where's that water level?
What?
Is it horizontal? Is it in the same level, or is it
lower? Gravitational equipotential.
Yeah. Does it follow gravitational equipotential to a lower height?
It's not correct to say that on a globe.
All right, so it would be horizontal.
Measured with distance from the center of the Earth out to the radial point.
What is?
What height is? It's measured from the center of the Earth and a radial point out.
Yeah, it's above sea level, isn't it?
Yes, which is measured. Sea level is measured from the center of the Earth to a radial point, and then you subtract that. But it's the same thing.
Really?
You subtract a number. Yes. Above sea level.
Yeah, I know above sea level. I know they do that. They get sea level and then they just measure horizontally, don't they?
It's similar to Kelvin and Celsius. You just subtract a number to get from one to the other.
From sea level to what?
From sea level, you'd add whatever the distance is from the center of the Earth to sea level. I don't know that off the top of my head.
Right, we just calculate sea level, don't we? We just go from sea level, right?
Yes, which is a distance from the center of the Earth radially outward.
So that level that you're thinking of there, does that curve? Because that sea
follows gravitational potential around the Earth.
Yeah, so that level is horizontal, right?
No. It follows gravitational equipotential around the Earth.
Okay, can please define level?
It's equidistance from a point, or surface feature, or line.
So imagine I'm surveying, and I'm surveying a point 100 meters away. What do I need to know when I'm getting my level out and setting me level up.
Small scale. You can approximate it to completely flat at 100 meters. It's irrelevant.
Oh, so that is flat.
It's so small.
Why did you say flat?
No, because it's so small,
Yeah.
you approximate it to flat because the curve is
You
completely irrelevant.
approximate it.
The
you
curve is
exact
about
it
half
to
a mil.
horizontal, don't you?
Sorry?
You exact it to horizontal, don't
No,
you?
you approximate the curve as horizontal. Because it's such a small scale, the curve is irrelevant.
Right, so you are saying that the horizontal is a curve, right?
No. You can approximate the curve and just assume it's horizontal because the effect of the curve is nothing. The effect of the curve becomes negligible at such short distances.
We're not talking geometric here, though, are we? I mean, this is fantasy, isn't it?
No, this is what surveyors do. So at work, I use something called the T3000 Lucia Wild theodolite. This has a mode setting in it to turn off and on curve compensation depending on the distance you're surveying. T1000, T2000, T3000 all have this mode, and it's dependent if you want to include the curve in your calculation or not. Now, whether you want that on depends on the distance. Now, I don't use these for surveying. I use them for optical testing because they're really good at measuring angles. But I know all the settings of them and how to use them. Why would they have this?
It has a theodolite is you look at something through a scope, right? Just to explain to everybody. You set it up, you level it up, and then it can define angles in the upwards and downwards direction and left to right.
So
right?
T2000 and 3000 are digital. These can measure distance for you. They can do load of stuff from the angle.
Do everything automatic. You press a button.
Yes, the T2000, 3000, you point it at a point, click set mode, I think it's 861 run, and it will save that point. Point it at another point, and it will give you the distance between them and give you measurements.
Cool. Is that like one of them things you can strap on the top of your car and go surveying? Driving with
I
your car?
don't use them on cars. I believe they can be powered from car batteries. I'm not 100% sure.
No, put them on the top of the car and drive around with them. Can you?
No, not at all.
No.
You need to be looking through them to do it.
So you need to optically look through these things like it's a telescope, right?
Yeah, we use cameras. But
and then when you switch the on and off curvature adjustment thing, does that, like what you're looking at, change?
No, it's calculating the distance from you to an object. It will include the calculation of the curve or not.
Okay,
but because the distance is so
between you and
small,
the object, right, changes if you can flick a button. It will change the distance to make it like you are on the curve or like you are on a flat. Which one does it alter?
Either way, it's a toggle. It's a toggle between the two. The thing is, on a very small scale,
they both can't be true, though, can they?
No. On a small scale, the curve doesn't matter. If I'm surveying, I don't know, 100 meter squared area, it's irrelevant, the curve.
You do often survey 100 meter square areas, do you?
Yeah, and I don't.
Oh.
But at that distance, the curve is negligible.
Okay.
The curve would be. I'm trying to do maths in my head here. I can't do trigonometry in my head. Can't do sines. I can't do that in my head.
Okay. No, but nobody's asking you to. Have you ever measured anything? What did you measure at 100 meters?
No. This is an example. You don't need the curve at that distance because the distance.
Wait a minute. You've got a theodolite at your place that can actually measure curvature, but you've never pressed the button to do that.
We don't use them for that at work. We do
but wouldn't that be cool? You should ask them next time if you can do it, just at dinner time.
We point them at.
Can I go out here and measure the curve?
No, they cost like 10 or 15 grand. Fuck all, are they letting me take it out of the building?
Well, you can measure the curvature in the building then. Have you not got any 100 meters?
These things are set up against walls because they're used to test things.
Oh, something goes set up against a wall.
So you have an object. We use optical things that have focus distances out to infinity, and you position that the theodolite. So it doesn't matter. There's a wall behind them, and it's more space efficient to put them against walls. It's simple.
Brilliant. Okay.
So it can't
Okay.
measure curve then.
Well, there's
Only in the
curve.
building.
Yeah, there's theodolites out there that can measure curve. Brilliant.
No, they take into account the curve when calculating the distance to an object.
Oh, can you
So
can you just give us the name of that thing?
Lucia Wild T2000 and T3000.
Lucia Wild.
It's like Wildy, Wild, something like that. It might have an E on the end of it.
Wild. What is it called? Give us the number again.
T3000 or T2000. They're very old now. Very old. All their new ones are digital.
Can't be that old.
Yeah,
Oh,
no. Their new ones don't use rotary encoders, and we need rotary encoders.
Okay.
So,
Okay. I'll have a look at that when we go searching with the surveyors.
I doubt surveyors will use them anymore. They're really old. They're from like the
Bev,
80s.
can you
at
just
this
get him
point.
to spell that Lucia?
Can you spell Lucia for us?
No.
Well, that's handy.
They were saying you're not so good at spelling. Luci.
No, I'm not good at spelling. Thank you for taking the piss out of flexibility.
Pardon?
I was making a joke, don't worry. If you search T3000 theodolite, they come up. Yeah,
Sweet.
just search T3000 theodolite, and they'll come up.
I'm interested in the curvature switch, but
It's just taking into account its calculations.
But if that has a curvature switch and a curvature flick, right?
Yeah.
Then how can my test not measure the curvature?
Because your test shows no difference between either model.
Why?
There is no, because your test follows on your idea of the. Let me finish.
Yeah, but we're just testing reality. We're not.
You said why? Let me explain. Your idea of the Earth has a horizontal plane, so you see horizontal surfaces of those tubes.
Just reality,
Now,
Nick.
No. The globe follows gravitational equipotential, and you see flat surfaces along gravitational equipotential, which is at a 90 degrees, not 90 degrees, it's parallel to the surface of the Earth.
Yeah, he doesn't
Which means that you
understand
don't see a difference in results either way the Earth is. This is the problem with your experiment.
Yeah, he doesn't understand that.
There is no difference.
He's muted you, Brenda. He doesn't talk to anybody, so.
Oh, I did. I talked to people
doesn't
last time,
lots.
and it was just people shouting. So
yeah, Brenda would definitely do that to you. It's a good, wise choice.
What
for
would
you
I
to
do?
that.
What would I do?
I just can't be bothered to deal with that many people again. It gets
You can't
boring.
be bothered with you, Brenda. Can you not hear him? Brenda can hear. You can hear.
They should be able to hear me. I've only muted them. I haven't deafened them.
Sounds like he's scribbling.
Sounds like he's Beelzebub, which is
playing with his crayons.
That was. Do you remember Sal, a flat earther from ages ago?
Who?
In that Sal, flat earther in that mega thread from ages ago. I think his account got restricted or something. He called me that. My username is what it was on here. And then he called me that. I found it funny, so I changed it.
Yeah,
brilliant. That's where that came from.
It's hilarious, isn't it? Beelzebub.
Yeah, I found it funny.
Yeah.
He was calling me the Antichrist, and I found that hilarious.
So Bev,
It's just funny.
Brenda, he doesn't want you joining in because he'll get awfully upset if other people start talking. You don't know what these Globers are like. It's terrible.
No, I did that last time, Bev. I just don't feel like doing it again. It's fairly simple. It wasn't fun talking to like however many people it was. I think it was 4 or 5 people. It just wasn't fun.
It was just a casual conversation, wasn't it?
I'm a Glober.
No, chocolate captain shouting. That wasn't fun, so...
Yeah, it doesn't matter, Brenda. It doesn't matter. He's a bit of a snowflake. He doesn't like anybody talking over him.
No, I don't. Nobody does. That's just human nature.
Yeah, you do that a lot, Bev.
Sorry?
Nobody likes being talked over. That's just human nature, Bev. And no, I just didn't find it fun last time with how many people there were. That's why. It just wasn't fun for me. And why would I spend my spare time? I mean, I still have to go to work at the moment, so it's not like I have infinite free time.
No, Bev, you talk over people an awful lot.
So why do something I don't find fun? Talking to one person's fun. Talking to loads isn't simple as that.
Yeah, you've got a bit of backup here. Did you call for that, Nick, or is it?
No, I didn't at all.
No. Oh.
If they
Brenda.
join the voice chat, I'll mute them as well. I asked for a one-on-one.
Yeah. See, Brenda, you're not needed. Nick can survive all on his own here.
Well,
Can't
I'm
you?
not
I asked
here.
for a
I'm not
one-on-one.
here
So
to
if they
back him
join,
up.
someone joins from my side, just mute them. Do the
Yeah,
same
what
as I do.
are you here for, Brenda? Been told
Oh,
Nick's
I was just
been told
interested.
to
I was
mute
just
you.
interested. That's all.
Well, the agreement was a one-on-one. It'd be unfair if that was one-sided. I didn't ask anyone to come here, so
No, this
it's
is
a one-on-one. Unless you want more people.
Yeah, we just chat here, though. I mean, this is what we do. But it's open. Anybody can come and have a chat with us about anything, really. It's like you want your super snowflake rules.
No, I just want
No.
normal debate rules, which isn't like 16 on 1 or however
No,
many people are here
Nick.
right now.
Nick, I know you've got your everybody muted, but nobody's talking over anybody. Even Brenda's coming. She's not trying to talk over anyone.
Oh, you said that last time, and then what happened when that chocolate guy joined?
Chocolate, yeah, he's known
Shut
for
up.
being a right rumpus, isn't he, Chocolate?
Anyway, yeah, your test won't show a difference in results either way. That's your problem you've got.
Okay. Well, no, that's
That's
just
your
your
problem.
point of view, though, isn't it? Like
No,
you're
that's
Not a
factual.
point of view.
You cannot state a difference in expected results.
So you're speaking for all of the globe believers, then, are you?
Can you state a difference in expected results?
Well, no, because it's
There you
a
go.
test.
There you go. That's it.
It's
That's
a
it.
test.
But your test
We are
doesn't prove
just
anything.
going to find out what it
But your test can't prove anything because there is
would.
no difference in
would
expected
be able
results.
to see if there was a curvature in it. It would.
No,
That's
you
what my
couldn't.
test is
No, it wouldn't.
designed for.
No, you
Because you have
couldn't.
no
Yes.
reference. You have no reference between the extreme left and right end. That's your problem. There is no reference you have.
It would.
You have nothing
With that
tying
straight
the-
line. What are you
Now-
talking about?
If you want to make
Level.
this test prove something, you can do it quite easily by shining a laser aligned with, say, the left-hand end to the right-hand end and seeing where it falls. That would prove flat Earth if the laser came in at the same angle as the surface.
Okay, so a laser is horizontal then. When you level a laser, that would be horizontal, would it?
Ignoring divergence, say you've got the correct laser, yes.
Right. So that horizontal is horizontal. That's
Horizontal.
That horizontal
Horizontal
doesn't curve.
to that point on the globe.
Right. So the light, the horizontal light, might curve, mightn't it?
No, light doesn't curve. We're not near a black hole.
Right. So light doesn't curve.
No, but it will
Ever?
only be horizontal. It will
Nick,
curve
ever?
around a black hole. There's refraction, but
That's not
curving.
curving light, is it? That's straight.
No, that's straight lines meeting optical interfaces. The only way to curve light would be round near a star or something of sufficient gravitational mass. But that's not going to happen on Earth.
Oh, so it happens angularly, then, does it? The divergence of
mean?
light, refraction. That happens. That's an angular change, is it?
Yes. But if you get lots of small changes and add them together, it appears as a curve.
Oh.
Lots of small changes will appear as a curve, but it is instantaneous angular changes at optical boundaries.
Right. So an angle is a straight line to a straight line, right? Like that's what an angular change means. Is it's not a curve change, is it? It's an angular change at an angle from a straight line to a straight line. Yeah.
How is this related?
Well, because we were doing this a bit before. I'm not so sure whether you got it or not.
No. There's a very much a difference. What we were talking about earlier was the parabolic mirrors. It's not a refractive matter. There's a big difference there.
Yeah, well, you said about we were just going over the horizontal laser light being horizontal, and that horizontal being a straight line.
No,
right?
It is horizontal to a point on the Earth, not the entire Earth.
But it is horizontal being a straight line, right?
Yes.
I mean, that's what horizontal is. Yeah.
Yes, but it's only horizontal to a point on the Earth,
Do you
not
mean
the entire.
to a point? It's a horizontal
It's a
line. It's a
curve.
straight line.
It's
Isn't it?
It's on a curve. It's only horizontal to a specific point.
No,
It's on a curve.
see, when you have a water level, where are you thinking or imagining that point that it is horizontal to? please.
Water level is horizontal to the point that is directly above.
Directly
Now-
above.
So the surface of the water will be approximately such a small scale as say horizontal. The surface of the water will be horizontal to the point directly above. Now, on a small scale,
No. You're gonna have to explain that a bit better. No. Which point that it is directly above? What are you talking about?
So these actual.
I'll put up the water
little
level
tube.
again and
I
just
know
remind
what a
you,
fucking
it's
water
just a
level
big
is.
tube
Yes,
of water.
it is
right?
not horizontal. It follows gravitational equipotential.
So where
Individual points
the point that it is horizontal to?
direct. Okay, so your surfaces of the water in the tubes, the surfaces at either end,
Yeah.
those surfaces will be horizontal to the point of the Earth directly below them.
Right. So 2 points
Yes,
on
but
the
they are
same
two different
horizontal.
They are
right?
not the same horizontal.
Okay. So if I was to drop a plumb bob right down on top of them 2 bits that it was horizontal, would they be perpendicular to the same horizontal?
No, because there's the curve of the Earth. You're following gravitational potential.
Brenda come to save you then in case you got
What
it
you
wrong.
I
want
wasn't trying to
understand
save anybody.
is that there is no down, no one constant direction of
Right,
down.
so which one of them would be vertical and horizontal perpendicular then? Which of the two at either end?
They'd both be horizontal to the point on the Earth they're above.
They would be perpendicular too, as well, would they?
Perpendicular to what? Sorry.
So the horizontal, like the vertical, the plumb bobs that it's in.
Yes,
So you get a
but
zenith
that's
at one
only at the
location.
point.
Only at which point?
that's just
At the point that the plumb bob is dropped.
Okay,
Yeah.
Because the Earth is
I'll
curved,
explain
it
how-
will not be vertical to every point. on the
Okay,
Earth.
so them horizontals would intersect then. Is that what you're saying?
Yes.
Right,
Because the
so
horizontal is different
therefore
depending
there
on the-
must be a rise in the middle of it, and my water test would be able to show that.
No, because the problem is your one's in the middle, also affected by the changing gravitational equipotential that
and
follows the
if
curve of the Earth.
the only way geometrically it could happen then, with verticals being horizontal perpendicular, it would be if they were all on the same horizontal.
No,
Surely.
no. You're not understanding is the
think
gravitational equipotential
that's what the horizontal
curves
is.
with the Earth. No, gravitational equipotential curves. Horizontal is defined by the position of the observer or plumb bob or whatever, because using the word observer, you're going to say there's no people involved, no doubt.
Well, it's
it
a water
changes.
level. You don't know how a water level works.
Yes, the surface of the
you
water
get-
in the tubes follows gravitational equipotential. It finds the points of gravitational equipotential, which is, on a small scale, approximately a horizontal. And that's a very important word there, approximately.
Geometrically, I mean, that's all you've got to go from, isn't it, really?
What do you mean, for what? Or you've got to go for what?
Well, how are you going to describe all of these things? I mean, like, I'm describing them vertical and horizontal and perpendicular.
They
That's
change
sort of
based on the position of the observer.
straight lines and geometry.
They
isn't
change
it? I
based
mean,
on the
that's how-
position of the observer. It's a lot more...
Even you were talking angles of change and stuff. That's geometry, isn't it?
The position,
Like when you draw
changes
a line and measure it,
depending
that's
on the
geometry.
observer. Where horizontal is, changes, depends on the position of the observer.
Sorry, say that again.
The horizontal plane changes based on the position of the observer on the globe.
So
Yes.
if I have a horizontal plane, right, and it's there, then I can make that change because I move.
The horizontal that you perceive will change.
Perceive.
Yes, because you're moving. So
Okay.
if you're saying,
so I'm at the side of a canal.
Let me explain.
And I'm looking at the canal, and then I move a bit. Does that make the canal move horizontally?
No, it changes your horizontal. The canal has always curved to follow gravitational equipotential.
So it is curved. You are saying it curves.
Yes, following gravitational equipotential.
Right. Okay. So then my water level test will be able to find out how much that curve is.
You need to explain how. How is it doing that?
By But once you understand how water levels work
No,
and
no.
link
Don't
that
say
to
that.
geometry,
No,
I will explain it to you. But you seem to be very,
precisely. Just don't explain.
struggling.
Explain precisely how it shows that.
Because
Use your
the
words, explain.
horizontal reference frame between the levels. Yes? Are you with me?
Yeah.
Well,
Keep going.
the horizontal reference frame in the levels shows that the big one is a horizontal reference frame. Now, the two smaller ones that are inside it have the same, or will have, a similar horizontal reference, except they only go halfway.
Yes, this is your problem. They are following gravitational
No, it's
potential.
not my problem. This is a test.
Yeah. No, this is the problem with your test. They are following gravitational potential, which means they would be the same on a globe.
Which means what? What does it mean?
They'd be the same on a globe. The results you would see are no different.
What does gravitational equipotential mean?
So
Other than just saying words, can you please explain it?
Yeah. No, sure. If you don't understand it, I'll explain it. Gravitational potential is the potential energy from gravity at a given distance from the center of an object. So potential energy is equal to mass times gravity times the change in height.
Is that space-time curvature?
It doesn't need to get that complex.
What do you mean?
You don't need to go that complex into physics for this.
Right. So what sort of gravity are you using then?
What do you mean? What type of gravity?
Exactly that.
No. Yeah, what do you mean? There's gravity. Oh, do you differentiate? Do you differentiate between Newtonian and Einstein? Is this what you're trying to get at?
He doesn't know what you're talking about.
No, because they're the same. If you take Einstein's field equations,
he says.
Let me finish.
Brenda says you don't know what you're talking about.
Let me say.
No, that's not what I said. You're lying.
Einstein's field equations, apply the limit of Newtonian gravity, which is low mass, non-relativistic speeds, and then apply the Ricci tensor to Einstein field equations, you get out the Newton's laws of gravitation. Now this shows that they are the same, just Newton was acting on a restricted view. He didn't know about relativity and all that stuff. They are the same. There is no difference between Newtonian gravity and relativistic gravity other than an applied limit on them. Mass, speed, can't remember if size is one or not off the top of my head.
Is that what makes a horizontal frame of reference curve?
No. You just asked if there's a difference for me to say which gravity I'm using.
Okay.
Do you accept, after me explaining that they are the same?
I haven't got a clue. I don't.
Okay.
It's an effect, isn't it?
No, listen. You just asked me to differentiate if I'm using Einstein or Newtonian.
Yeah,
Do
no,
you
I
accept?
just wanted
No,
you
listen.
to
Let me answer
say
the question.
whatever you said.
Do you accept, with my explanation, that they are the same?
No.
Why not?
Because you just said a load of words, and they definitely weren't the same.
They are the same. The difference is one acts within a restricted limit. Okay. So Newtonian gravity has a restricted mass it works at. If you go too high mass or too low mass, it doesn't work. And if you go too fast, it doesn't work. But this falls out of Einstein's
things
field
that it
equations.
doesn't work.
This falls out. Listen, if you apply these limits to Einstein's field equations, you get these laws. They are the same. One is just a better understanding of the principle.
Okay, so it's just an effect, and if we can bring it
No. Where are you getting the effect from?
No.
Explain.
Reality.
Your understanding of gravity.
Bring it back to reality, because this is what we're talking about, the water level test.
Yes,
and the way that you can't seem to differentiate between a straight line and a curved line.
The problem is you can't explain to me how there is a difference.
There is a difference in what?
Between the results.
Nick?
Between the expected results.
Between what results?
If your water level test on a globe or a flat Earth or whatever the fuck you want to call it.
I'm going to do it in reality, Nick.
Yeah, no. You're going to do it in reality.
Yes.
You get your results.
Yes.
Okay. How do you tell which one it is from these results?
You just look at the results first.
You look at the results first.
Well, after we've done it, yeah.
You've never done a science education, have you?
Okay, so
that basically invalidates your experiment.
No.
You are aware of that.
Nick, this is what we're trying to say, right? I've designed a test that I think will show something. Now, it's you that says you don't know what I do, that I'm going to say what the test is going to make because I don't know when it curves.
Your test will show the same results either way.
Yes.
That's your problem.
Listen, Nick. I designed a test because somebody said that teaching level is a straight line on a horizontal plane is child abuse. So I made a test.
That person is right.
I made a test to prove that it is horizontal level.
And you're trying to prove something, which means you have expected results.
We'll find out what them results are.
No,
you say
that's not expected results.
You say there will be no difference between reality and horizontal.
What? No, I'm saying that your results will show the same height across the water levels. There won't be a difference in between expected results for flat.
That's horizontal, Nick. No. That's horizontal. Yeah, that's what the water level test will show. Is the water level is horizontal. That's it.
You're failing. No, you don't have difference in expected results.
What do you predict would happen, Nick?
There will be no difference in results for either model.
No,
this is the problem.
What model, Nick?
Globe, and then whatever flat Earth.
Right. So you're saying on your imaginary globe model, the results of my test will show horizontal plane, and that is what you would expect on your model.
Yes, they would show the same on the Earth is flat or the Earth is round. They would show the same results.
Okay, is that because one of them's imaginary?
No, because your water level is following gravitational equipotential. This is the thing. I can predict the results using the known science. Okay. Can you?
But the results wouldn't be the same, Bev.
Can you predict the results?
He thinks they would be the same, don't they?
They would be.
Yes, they would be.
They would be exactly the same, would they?
From my understanding of the flat Earth and how it's been explained, you would expect the same results on a globe and a flat Earth. Yes.
So that makes
the flat Earth, your flat Earth lot just shout density when I ask what gravity is.
No, Nick. See, you have a shape, and we don't. We have a horizontal frame of reference.
You do have a shape, Bev. You do have a shape.
You don't. It's not horizontal. It follows gravitational equipotential.
Pardon?
It follows gravitational equipotential.
What follows gravitational equipotential? What does that mean?
Surface of water. It's quite
perpendicular?
Simple. What?
Is it perpendicular?
To what?
Perpendicular. Do you not know what perpendicular
Yes, I know, but perpendicular to what?
Like a perpendicular is perpendicular to its perpendicular. Do you not know geometry, Nick?
Yeah, you said, is it perpendicular? Perpendicular to what? What two things are perpendicular? Like, what are you going on about?
What were you talking about?
I was saying that gravitational potential, the surface of the water, will be at the same height as gravitational potential. It will equal out across the entire surface.
I said, is that perpendicular?
No, it's parallel.
What? It's parallel to the surface of the water.
It will be parallel. Yes, gravitational potential acts from the distance from the center of the Earth. So yes, it's radially out. Not radially. That's wrong. Spherically outwards. It doesn't act as a radial. It's not a magnet. It's not a magnet. It's not an electrical charge.
Okay, so it's curved, right?
Yes.
You imagine that horizontal frame of reference dictated by a water level is actually curved.
Yes.
Okay.
It is curved. Follows gravitational potential, which is a curved surface.
A horizontal frame of reference is actually curved. Fine. Fine.
You're claiming it's a horizontal frame of reference. It's not.
It is. It is. That's practically you. If you never leveled that theodolite
Use auto collimation.
You do know what level means, don't you?
Yes.
I mean,
Here's the thing. Level is not equal across the entire planet. What is flat, horizontal, vertical are not the same at every point on the planet. You're not kind of grasping this, that it changes as you go around the Earth.
Okay, I'm going to have to go for my tea in a bit now.
So I've got work tomorrow.
Well, there's loads of other people willing to talk about this, so...
Well, I've got to go. I've got to have dinner and go to work.
Right. Well, do you want to have a word with your other people and decide if you think that you can get a test that would prove...
You simply put a laser across your water levels. That's it. Put a laser across from one end of your water levels to the other end.
And okay, so how far a distance do you reckon?
The longer the better.
Right, go on then. Give us a distance. Give us a distance.
I'd have to do the maths. I don't
Aaron
know
Burrell, one of the surveyors, says 1/4 mile. Do you reckon that's a good distance? Is that enough?
How accurate is your detection system?
In fact, he described it as like a disco ball with 1/4 mile.
Here's the problem.
Horizontal planes. That's how he described it.
The problem is how accurate is your detection. If you're using photodiode arrays, you could probably do it over 100
using
meters.
surveying tools, no doubt.
Okay, for the laser, how far you need for the laser?
Why do you need a laser?
Across you asked an experiment to show the level occur. I said put a laser across your water levels, and then you asked how far do you...
Has level changed since lasers were invented? A laser's the new standard for level.
Lasers will draw a horizontal plane that do not follow gravitational a horizontal plane from the point they are shone. If you align
would
them
optical lasers that you look through, would they be okay?
That you look through? What do you mean?
Well, like normal levels, like a dumpy level or a theodolite level, like you have at your place.
Oh, they're not lasers. Sorry.
No, I know, but I'm just asking. They are optical. Now, are they horizontal? Because you've just said lasers so far.
If you align them horizontal, they will be horizontal at the point. Yeah, if you've got a powerful enough scope, you could use that as well.
Brilliant. Now, what about a water level? Would that be
water
horizontal?
level follows gravitational equipotential.
Right. So that not the water level.
Not the water level. Water level will be close enough on a small scale to be used.
Okay. Right. So brilliant. So a water level actually curves, whereas a sighting level or a laser level don't. They're horizontal level, and the water
they're not
level
affected
is
by gravity.
Right?
Yeah, level means curve.
What about water level? I didn't catch that.
Bev.
Sorry, Brenda's jumping in on you there. Sorry, what was that?
It's an open discussion.
not
it doesn't
Brenda.
matter if B8 has everybody. If B8 has everybody muted, that's his fucking problem. So Bev, when you
no, Brenda,
what?
you've been asked to shut up, please.
Why?
Because that's what we're doing.
Today you're having a conversation. That's why
it's a conversation.
They're having a combination.
Yeah, no, it's Nick and his snowflake rules. So I'm going to be going in a minute anyway, so you can talk in a minute, Brenda. I was just wrapping it up with Nick. Is that okay? Brenda, you all right with that?
Yeah.
Brilliant. Thank you very much. Carry on, Nick.
What were you saying about water level? I didn't catch that.
I was just trying to make the differentiation between the laser horizontal level and the optical dumpy theodolite level and the water level. Now, you say there is definitely a difference, right?
Yes, the water level is affected by gravity. The other two aren't. Or they aren't on the scale of the Earth. Gravity is not high enough here to affect
Where is the differentiation made in the word level that changes a surveyor's level used optically, laser, whatever, with the water level that was used way before they brought them? Is there a difference in between the two different types of tools?
They were used for the same thing. That doesn't mean that they are as good at it. Over a long scale, the water level will not form a horizontal plane.
Okay.
Because it's affected by gravity.
What sort of scale would you be saying then? That
depends what accuracy you want.
Water level does not establish a horizontal plane of reference.
It depends on what level of... If you want it down to a sixth of a radian, probably 4 inches.
No. I would just have to... 4 inches, you'd be measurable.
A sixth of a radian.
Let's say 2 miles. Is 2 miles enough for it to be horizontal?
I said to depending what level of accuracy you want it to.
Okay, all right.
I don't know.
2
Does
miles.
it matter if that from one side of the house to the other, it drops 2 microns? Does that matter?
Okay. Listen, 2 miles.
Right. I wouldn't use a water level over that distance.
No, because why wouldn't you use a water level?
Because it's following gravitational potential and it won't form.
Because it wouldn't have a horizontal frame of reference over 2 miles.
It wouldn't form a plane between the two. No.
Okay, right. I'm going to go now. I think I'm ready to leave it at that. I've got to go for tea. I'm being shouted at.
Yeah, I've got to go make my dinner.
Cheers, Nick. You want to unmute everyone and then you can say goodbye and thanks for not interrupting you.
I can say thank you without unmuting. Yeah, thank you for not interrupting, despite the fact I forced you to not interrupt.
Yeah, there was only Brenda, really.
You understand that not everybody here is a flat earther, right?
He won't be unmuting you, Brenda.
Oh, no, I have. Because you were talking directly to her, so I wanted to know what was being said. Yeah, I know they're not, but I wanted a one-on-one with Bev. That's what I've been trying to get. So...
Right. See you in a bit.
I just wanted to know him specifically. That's all.
But you were talking about field equations and tensors, and Bev doesn't understand what level means. You're talking way too high a level.
Yeah, I know. This is coming from... I've had a very long series of Twitter interactions with Bev, and I was talking to the level he pretends to be at. That's as simple as that.
Oh, I can understand that, yeah.
Kicking me. I was talking to the level that Bev was pretending to be at, that's all.
Bev, do you understand that on the globe Earth, plumb lines are not parallel?
That's a claim, Brenda. Can you prove it?
Yeah, I posted a link to a video talking about it.
From the drain surveyor. Yeah, really.
Yeah.
Is Bev still here?
I would imagine he just left to go get, as he said, tea, since he didn't respond.
Yeah,
so,
Bev's gone for tea.
On a globe Earth with gravity, plumb lines will not be parallel because they will point to the center of the Earth. They will be radial. They won't be parallel.
But surely, if you live on an oblate spheroid, then the center of the Earth would be different depending on where you are on that oblate spheroid. Well, how can it not be? How can it not be, Brenda? Because your surface position on an oblate spheroid from the center of the Earth is different depending on where on that spheroid you are. Obviously, if you're on the equator, you're going to be further away from the center point than if you're at either one of the poles.
Yes, that would be a difference. I don't know if that difference. Excuse me. I wasn't done. But that difference is not. Excuse me. That difference would not be. That difference would not be significant. It might not even be. It might or might not be measurable. I don't even know.
All right. Okay. So that's a claim. Have you got anything to back that claim?
The video talks about that.
All right, well, I'm not going to sit here and watch the video.
Yeah, you're not going to watch.
You're the one that posted. You're the one that posted the video. So I take it you have seen the video.
The proportion.
So where in this video does it cover the subject that I've just raised? Where
on an oblate spheroid. That.
Hang on, can I finish? On an oblate spheroid, depending on where you are on that spheroid, you are at a different distance from the center point of that sphere. Can you tell me where? in the video? That might be.
It would not be significant because of the size of
This
the
is your
Earth.
claim, Brenda.
And
This is your
excuse
claim.
Excuse me.
This is your claim.
Excuse me.
You claimed
Excuse
this.
me.
You claimed this before.
Excuse
Brenda,
me.
you claimed this.
Excuse me.
You claimed this before.
Excuse
I
me.
asked you to back it
No,
up.
excuse me.
And
I
now
wasn't
now
done.
you're claiming it again.
Your
Now
No.
you're
pardon.
claiming it
Excuse
again.
me.
Asking to be
Now,
You're
just
excused.
listen. Excuse me.
You're excused.
Listen.
Exit stage left, Brenda.
So the point
Goodbye.
is,
You're excused.
no, go away. So the point is that
Go
that
away.
on a planet the size
dear.
of the Earth, the difference
you're claiming
is very
again.
small.
You are claiming.
That's not a
Yet
claim.
Again. It
That's
is
not a claim. No,
it's
it isn't.
it's words from your mouth, Brenda.
No, it's not a
This
claim.
is a claim.
It's a
This is a
fact.
Yeah,
It's
Brenda,
a fact
maybe.
that given the size of the Earth and the amount of deviation from a perfect sphere, the proportional to us, to human size, it's incredibly small.
Okay, Brenda, do you know what the claimed oblate spheroidness is? How much further away from the perfect sphere your oblate spheroid is at the equator? Do you even know that?
It's very small. It's very small.
Do you know how much it is?
I don't know the exact number.
Well, Brenda, how come you're just spouting rubbish now?
What is the exact number? What is the difference?
21 kilometers.
Yeah, over 26,000. That's a margin
Brenda,
of error that is very, very
21
small.
kilometers on a 24,000
Yes.
mile radius.
Yes, and in proportion, compared 21 kilometers compared to 26,000 is very small.
Brenda, you have nothing to back your claims.
What's the
You're just saying words, Brenda.
No, I'm not just saying words. I
Well, yeah,
told
you
you.
are. Yeah,
I
you are.
told you about proportion.
You posted a video, a link to a video by the drain surveyor. But other than that, you're just spouting words. You can't even say it on the
No,
video.
I'm not just spouting words.
Yeah,
the
yeah,
point
you
is, the point is that on a planet the size of the Earth, the difference of 20 miles or so in proportion 21, big deal. In proportion to 26,000, which is the circumference of the Earth.
24,000. Brenda, you're not very good with
it doesn't
your numbers,
matter.
are you? You're
It
not very
doesn't
good
matter.
with your own numbers. You don't even know
It doesn't
your own
matter.
model.
It
Brenda,
doesn't
you
matter.
don't know. It doesn't matter that you don't know your own model.
Yeah,
how does that not matter?
It doesn't matter. It doesn't matter
Brenda,
because it's not a difference.
Brenda, listen to yourself.
It's not a huge
Step
difference.
back and listen. Listen to yourself, Brenda. You don't even know the circumference of your own model. You don't know how
It
much
doesn't
the
matter.
oblate spheroid bulge is. What do you mean it doesn't matter?
It's 21 miles. It's 21 kilometers. It's nothing in
Brenda.
comparison
Oh, which is it?
to
Miles or
24,000.
kilometers?
It doesn't
Is it miles or
matter.
kilometers?
It doesn't matter. The proportions. The proportions matter.
Brenda.
The proportions matter.
Brenda.
The
How's your
proportions
shoes?
matter. The
How's your
proportions
shoes,
matter.
Brenda? How's your shoes?
So
What
21
about shoes?
Nice shoes today?
and
What about shoes? You don't know
26,000,
anything about that.
because
Or the
26,000 is a bigger
The
number
ground
than
is in the
21.
apple's future.
It doesn't matter in proportion.
That's a direct quote from you.
You don't
Related
know
to
what that
gravity.
was about.
Yeah.
You don't understand what I was talking about.
Really? Like
What was I
wasn't
talking?
listening.
What was I talking about, Lev?
Well, gravity, obviously.
No, I wasn't talking about the shoes. The shoes weren't about gravity.
No, the apple. The apple was the last thing we spoke about. Remember? You having problem keeping up, Brenda?
You were talking about shoes.
The shoes were before the apple. Then we spoke about the apple, and then you asked me what
You
it
were
was
talking
about.
just now about the shoes.
Yeah, but then I spoke about the apple,
What about
and
the
you
apple?
asked me what that was about. Well, gravity. The
Yeah,
ground
what about
was in
it?
the apples. The ground was in the apple's future. You were
Yes.
describing gravity.
Yes, that's how it works.
Really?
Yes. That's how
Okay.
that's
But
how relative.
Yes. If that's how you believe it works, then your belief
It's not a
system is
belief.
up to you.
It's
It
not a
is a
belief. That's
belief,
the
Brenda.
science.
It is a
that's not.
belief.
That's the science.
All right. So the apple was in the ground's future is a scientific method.
I didn't say.
You just said it's science,
I didn't.
Brenda.
You're misstating what I said.
Brenda, can you stop contradicting yourself, please?
I'm not. You're misstating what you're misquoting me. You're misquoting me.
Brenda, you are contradicting yourself.
No, I'm not.
Brenda, step back and listen to what you're saying. You don't make any sense.
The fact that you don't understand it doesn't mean it doesn't make
Brenda,
sense.
You can't say that I don't understand because you don't
can't
know.
You can't even quote me correctly.
I do and I don't understand.
You can't even quote me correctly.
The ground was in the apple's future. That is a direct quote from you, Brenda. That is a direct quote from you.
So the point is that in
the point is you just said that
you're just going to keep interrupting me. I'm not going to interact with you anymore.
Brenda, you're not making any sense, love.
It is sense. It is. This is relativity. This is relativity. This is how relativity works.
What? One shoe relative to the other shoe.
We're not talking about shoes. We're talking about apples. Now you're pretending. Okay. Are you going to pretend that I don't understand? I'm not following the conversation because you introduced something new. The way relativity works.
I've been listening to you guys fucking do this for about half an hour now. Okay.
It hasn't been half an hour. It's been only a couple of minutes.
Brenda, I'm fucking talking.
Who's saying about half an hour? I didn't say anything about half an hour.
This isn't half an hour. So the way relativity works is that all things follow geodesic lines on the curvature of space-time. So the reason the apple falls is because the ground is in the apple's future. It's along the geodesic line, the world line of the apple meets the world line of the ground.
Okay. Well, what if I put a pillow underneath that apple?
What of it?
Then the ground is in the apple's future.
I'm sorry, I accidentally clicked something. What did you say? Please repeat.
Oh, Brenda.
I accidentally clicked out of the channel.
Does anybody else want to go at this? I'm bored with.
So the point is that all things have a world line which they follow, which is the curvature of space-time, right? Which is things are always traveling in the future. You can't travel into the future.
Right, hang on.
Right. So when the apple hits the ground, when the apple hits the ground, it's because the world line of the apple intersects with that of the ground in the future.
You brought in the curving of space-time, right? Space is a concept. Time is a construct.
No, they're not.
Yes, it is.
No, they're not.
Yes, it is. You cannot bend either one, Brenda.
Yes, you can. We can, and we have.
And you were saying about the apple falling to the ground. Well, this is a different definition of gravity, isn't it? This is Newtonian gravity. The bending of space-time is Einsteinian gravity.
I'm talking about Einstein. I'm talking about relativity.
Make up your mind which one you want to talk about.
I've been talking about relativity the whole time.
Right. So the ground being in the apple's future is relative.
Right. The ground intersects. The ground intersects. The ground intersects. The ground intersects with the world line of the apple.
So if I put a pillow underneath the tree, then I've just stopped that intersection. I've just changed your gravitational model.
Well, yeah, you put something in the way. What's
so I've changed your model.
No, that's not changed the model at all.
Yeah, it is. The ground is no longer in the apple's future, Brenda. The pillow is in the apple's future. What happens if I pick that apple and it doesn't fall?
What are you talking about?
Well, yeah, Brenda, this.
What are you talking about? You're just spouting gibberish.
To say the ground is in the apple's future is nonsense, because the ground is not. It is not in the apple's future, is it, love? You can go and pick the apple. You can go and pick the apple from the tree. The ground is no longer in that apple's future. You can put a pillow.
You don't know what you're talking about. You're just talking gibberish, as if you can change things. right?
I can't go and pick apples from trees. Is that what you're saying?
No, the point is that you're just making shit up. You're just making shit up.
No, Brenda, I've just outlined what a complete and utter knob you are.
Well, you can think that, but you're wrong. Everything I've said, everything I've said is standard science of today. Everything is relativity,
Brenda.
and how things work in a four-dimensional manifold of space-time. That's how it works.
4 dimensions.
Yes, it's 4.
Don't we just live in 3 dimensions?
No, it's 4.
Oh, right, so you're not in reality.
Reality is 4.
None of what you've said is real.
Reality is 4.
Is based in our 3-dimensional physical realm.
No, we live in 4 dimensions. We have the 3 dimensions of space, and then the additional dimension of time.
And this is Brenda's world, yeah?
No, this has been relativity for over 100 years. It's 4-dimensional.
Brenda, you're
are
nonsense.
you moving?
You are absolute
You can
nonsense.
just be confused about it. You can not understand it. Can you stop moving forward in time?
Can I stop moving forward in time?
Yeah. Can you stop moving forward in time?
Time is a concept, Brenda.
No, it's not.
Yeah,
yes, it is.
No, it's not.
Going forward in time. Yes, I can think about what happened in the past. There you go.
Yeah.
That's not moving. That's just reflecting. Can you stop?
I went to the past, didn't I?
No, you didn't. You imagined the past.
How the fuck did I know what that'll happen back there then?
You have a memory.
That's in the past.
No, your memory isn't.
I can access whenever
I want to. Your memory isn't in the past. Your memory is in the present with you.
You hurt my fucking head.
You can't stop. Yeah, can you stop aging? Can you stop aging?
Brenda, answer me this one, all right? The inventor of the first clock, how did he know what time it was?
Time is just a measurement
How did he know what time it was? How did he know that it's midday to set his very first clock by? How did he know that?
Clocks measure the time between events. So it doesn't. There's no.
So who set the first clock? Who set the first clock? How do we know it's midday, Brenda? Who was it that made a concept not tangible? I was going to say physical, but that's not the right word. So tangible. Who was it that made a concept, meaning I can see the sun rise, I can see the sun set. There is time in between those 2 events.
Yeah, and midday.
So who made that tangible? Who said, right, it's now midday, I've invented a watch or a clock. Ta-da, there we go, midday.
Yeah, well, you just define an arbitrary starting point. That's all.
Oh, Brenda, you're full
That's
of nonsense.
How it works.
Absolutely.
You just define midday when the sun is directly overhead you.
You've just said time is arbitrary. You just set an arbitrary.
No, I didn't say time was arbitrary. I said you define
you just say
No,
you set an arbitrary.
No, I said time is an arbitrary. You just define an arbitrary starting point.
Oh, exactly. Time is arbitrary. You just said it yourself.
No, time isn't arbitrary. The starting point is arbitrary.
So therefore, the time itself is arbitrary.
No, that doesn't follow. That doesn't follow.
Can you not see how circular your reasoning is, Brenda?
That's not circular.
The starting point of time is arbitrary, so therefore
it's not the starting point of time. It's just the starting point when you decide to measure time.
So the measurement of time is therefore not arbitrary.
The starting point is arbitrary.
Your head is in knots, girl. Your head is
you don't understand.
Knots.
You don't understand.
You can't say that I don't understand. You don't know what I understand.
Yes, you don't understand.
You don't know what I do understand, and you don't know what I don't
I know that you don't understand hardly anything.
I know that you're talking absolute shite, girl.
This is standard
obvious.
Physics for over 100 years.
Brenda.
This is standard physics for over 100 years. We live in a 4-dimensional space-time, right? That's standard physics for over 100 years. We live in
Brenda.
4-dimensional space-time.
Brenda, I've got some advice for you. Pull your head out your arse, girl. Get in the real world.
Do you not
Get
agree
in the
that
real
you
world.
can you stop aging, Lev? Can you stop aging?
Lev.
Can you stop?
Lev, yeah.
Well, that's what I see. That's all I know of him. That's all I know is Lev done curving. That's all I know.
Yeah.
That's the person I'm talking to is
the
Lev.
level is done curving, Brenda. The level is done curving. That's
So can you
what we're
stop
here
aging?
for.
Can you stop aging?
Well, no.
No,
But that's a biological process.
No,
It's not
it,
due to
and it
time.
happens in time, doesn't it?
It happens.
It happens in
but
time.
It's not due to.
Can you
time,
age in a
Brenda.
concept?
That's the difference.
Can
That's
you
the
age in a
difference.
concept? Can you
A
age
concept
in
can
a
be whatever you
concept?
want it to be. A concept can be
Right.
whatever you want it to
But
be.
you can't
Brenda.
stop aging, can you?
No,
So
because it's a biological process.
So
It's
how
not
can you age
down
in
to
a
time.
concept? How can you age in a concept?
A concept can do whatever you
Is it
want
just a-
it to.
is
It's
it just a concept that
conceptual
you're
by
aging?
name and nature. A
Is it
concept
a concept that you're
conceptual
aging, or
by
is it?
name and nature. It is a biological process that I am aging
Yes.
in time.
A biological
Brenda.
process
Don't you
that
understand
occurs
the difference?
in time. Time
You don't
is
understand
physical.
the difference.
Time
it's not
is
physical.
Yes, it is.
Brenda, it's a construct.
No, it's not. You can't stop
So you can
aging.
touch time. I can go to the shop and I can go and buy, what is it, a pint of time or a gram of time? Or
No,
is it
you
a
can
table?
measure.
Is it a table of time?
You can
it's
measure
a table
time.
of time, isn't it?
You
I
can
know
measure.
times tables. There's 2 times table. There's 3 times table.
So now you're confusing time with multiplication?
Well, you're talking about time in your table, weren't you?
Why are you confusing time
How
and
much
multiplication?
time is in your table? I'm not confusing.
Yes, you are. You
Brenda,
just did.
You're talking about times table. Time
No,
in
I'm
your
not
table.
I'm not
There is
talking
no
about
time
multiplication
in your table.
tables. I'm not
only
talking
time
about
in
them.
your
That's
table-
you not
If your
understanding
table
basic
is wood,
words.
If your table is wood, the only time in your table is the amount of time that it took to grow the tree, the amount of time that it took
Yes.
to chop the tree down, the amount of time to manufacture that table.
I can measure
But
that
there
time,
is
can't I?
How can you?
Can I measure that time?
The only way you can measure time in a tree is by counting the rings.
No, you can measure time with clocks. You can measure time with
in a
lots
table,
of things.
how is your table a clock?
No, I can measure time.
Hang on, wait a second. You asked me if I could measure the time in your table.
No, I didn't.
I said, yes, you did. Brenda,
No, I didn't.
All you got to do is go.
I
all
asked
you got to do is go back and listen. Look.
No, I
can
didn't
finish?
ask that.
Brenda, let me finish. And I said the only way you can count time in your table is to count the rings on the tree. And then you.
Oh, we were talking about
claiming
trees, not tables. We're talking about trees, not tables.
Brenda, pull your head out.
A tree is not a table.
Conversation.
So you'd measure
I didn't
time.
say the tree.
You would measure time with a clock. Lev, you would measure time with a clock.
Oh. Do you know how many times I've laughed at you on Nathan's Right? And
I don't care.
Now
what do clocks? What do clocks measure?
I'm having with you is funny.
What do clocks measure?
A concept.
What? No, they don't. What
Yes,
do
they
clocks measure?
So how do I buy time if it's physical? Where do I go to buy
How
time?
How can you measure something that's just a
buy,
concept?
Where can I buy 20 more years for my life, Brenda?
How can you measure a concept?
You tell me, how did the person who invented the clock say, right, now is midday, I set my brand new one in the world, only one ever, 12 o'clock, bang, there we go. You tell me.
Well, he defined...
You're the one that says it's physical.
Well, you have to actually allow me to answer you. You have to actually allow me to answer you. So the answer is, he simply defined midday as when the sun was directly over his head. That's how he did it.
No,
That's how he did it. Midday is when the sun is directly overhead. There, done.
I'm clipping out. I keep clipping. Hang on, let me drop and come back again.
Turn up.
The radio. It's a shoe. How much time is in your shoe?
That's not the point.
Nah.
Well,
You don't understand. You're not being able to
drops out
understand the example. Doesn't mean it was false.
No. What if we do understand? It's just
But you
stupid.
don't. What was the shoe in reference to?
The shoe was in reference to a really cool Corona song.
No, it wasn't.
And it had your face on it going, shoe.
That's not what it was about.
I thought it was pretty funny.
I don't care what you think.
Well, that's frickin' clear.
Right. So the
But
shoe.
it would matter.
The
It
shoe-
would matter if I thought the Earth was a globe, correct?
The shoe was about whether or not we could do
Answer the
scientific
question.
experiments on
Answer the question.
man-made objects. That's what it
It
was
would
about.
matter if I thought
yeah.
the Earth was a globe, wouldn't it?
You would still be wrong.
It's a shoe.
I would still be
Thesis, it's a
wrong if I
shoe.
thought the Earth was a globe, correct?
No, you would still be
Conclusion,
wrong
it's a
about the
shoe.
shoe, even if you believed in the globe.
Ooh.
So what was
What
the
did I
shoe?
miss?
What was the shoe
What's the
about?
fucking point of the shoe?
Hey,
then?
Bev.
No, it was a hypothesis. It was a hypothesis, wasn't it, Brenda? You
No, it wasn't.
hypothesized a shoe, and
No.
therefore it was a shoe.
No, that's not what it was about.
It was to do with the scientific method, anyway. It was
Yeah,
to do with the
it was
scientific
to do with
experiment.
It was the fact that you can conduct experiments on man-made
So
objects.
shoe, therefore shoe.
No, that's not what it was about. You don't
Right,
understand.
Okay, whatever. Yeah.
It was
well,
about
Brenda,
it was
I-
about
I-
Nathan. It was
Brenda,
about
to be
Nathan
honest,
lying about
Brenda,
the
I
scientific
I
method.
don't care about your shoe.
Yes, I know.
I don't
You
care
don't
about
want to
your shoe.
know that it was about Nathan
No.
lying about what the scientific method was.
Well, do you know, Brenda, right? My conversation with you for the last, what was it, 20 minutes maybe? I don't know. I haven't really been counting, right? I haven't got a watch to keep time, so I must go down the shop to go and buy
So,
a
table.
pound.
It wasn't really a
pound of
conversation
time?
because you just
Table.
talk over me all the time.
No, because you just absolute waffle, girl.
No,
Absolute
I didn't. Not
horseshit
at
from
all.
your mouth.
Your
Brenda,
incredulity
do you know
doesn't
how
mean
many?
it's
Do you know
false.
how many times? Do you know how many times you contradicted yourself, girl?
I didn't contradict myself at all.
Well, go back and listen to this after because it'll be
All
going
right,
up on
that's
YouTube.
fine.
And absolutely hilarious the amount of times you
Well,
contradict yourself.
You think it's
And, you know,
ridiculous that we live in four-dimensional space-time, but that doesn't mean it's false.
Hang on, Brenda. You just said it. I think it's ridiculous that we live in four-dimensional space.
Space-time.
No, that's not me, girlfriend. You've just described yourself.
We live in four-dimensional space-time.
Oh, so
That-
it's not me that lives in four-dimensional space-time,
We
like
all
you
do.
just
We
asserted.
all do. I didn't say that you.
No,
that.
no.
I didn't say that. You're
Yes,
lying.
you did.
You're
you
lying.
Said you said I believe that I live in four-dimensional space.
Yes, we do.
No, I don't believe that at all. So you have just
It's not what I
contradicted
said.
yourself yet
That's not what
again.
I said. That's
You've
not what I
just-
said.
Brenda, you've just contradicted yourself yet
No,
again.
I didn't. No,
Why
I didn't.
Why can't you keep up with the conversation, Brenda? Are you mentally deficient?
You're misquoting me.
Do you take pills?
You
Has
are
this
misquoting
lockdown
me.
stopped you from getting to
This
the
is just
hospital
you
to
being
get
a
your
dick.
medication?
So the
Brenda,
thing is that we live
you
in
haven't-
four-dimensional space-time. That you
No,
think
this is your belief.
that
This
you
is
think
your
that that's
assertion,
funny.
but you have
That you think
have
that
no
that's
proof.
ridiculous and that you can't
You have no
understand
proof,
that
Brenda.
doesn't mean it's
You have
not
no-
true.
This is an assertion of yours. This is an opinion of yours.
And it's not
that
an
you cannot
opinion.
prove.
It's a scientific
It is.
fact. It's not opinion.
Oh, come on.
So where is your citation? Where is, as QE would
it's
say,
the whole
where is
of-
your cowbell?
The whole of science since Einstein.
So give me a citation. Give me something to read.
All
Give
of
me something to-
science, all relativity since Einstein.
Brenda, You are mental, girl.
Yeah, you can
You
say
are absolutely
that relativity.
off your chuff.
Yes, you can say that relativity is nonsense. You can disbelieve it, but it's a fact. It's not an
Brenda,
opinion.
but
It's a fact.
I don't have to believe it. It is your opinion.
Yeah, you can disbelieve it
until
all
you
you
give
want.
me a citation, until you tell me something that is tangible, and until you tell me where I can go and buy time by the pound or by the pint or by the litre.
Nobody's claiming that you can buy time by the pound.
You said it's physical.
Yes,
you said time is physical.
Yes, that doesn't
So
mean you
where-
can.
where
That
can
doesn't mean it has weight. That doesn't
So-
mean it has weight.
So something that's physical doesn't have weight.
There are things which are physical which do not have
Such
weight.
as-
Yes,
such
such as light.
Light. So light's physical.
Yes, light is physical.
Well, if we believe your scientists, right, they have invented solar sails. You know what solar sails are?
Yes, I do.
Yeah. So this would lead you to believe that light is physical, wouldn't it?
Light
there is
is
something-
physical because it's
Like
a part of the
there's-
physical world.
Yeah, Brenda, who actually knows what light is? Is light a particle
yes.
or is it a wave?
It's a wave packet.
A wave packet.
Yes.
A packet of waves, like a packet of crisps,
Yes.
like a pound of sugar, like
Yeah.
a litre of time.
No, exactly like a packet of. I don't know what
Brenda,
you mean. A packet
are
of crisps.
So,
Well, you can
what do you
disbelieve
call
it.
Are you
but that's the
American?
fact.
Are you American?
This
Are
is
you American?
this is physics,
are
and it
you
has been
American?
physics for a long time.
Are
Light
you American?
is a quantum of wave energy.
Are you in America?
Yes.
Yeah. Oh, chips then, not crisps. Chips to you. A packet of chips.
Whatever.
A litre of milk. A pound of time.
Light.
Please,
Light
Mr.
is
Wholesaler.
light is a wave packet. It is a quantum
Oh, yeah.
of wave
Okay.
of wave energy. That's what light is.
Okay, Brenda. You got citation? You can prove this, or is
This
it
is
just words? It's just words
No,
from
this
your
is
mouth.
any
No.
high school physics
No,
book
Brenda,
will tell you.
Brenda, this is just words from your mouth, love.
Yes, it's words from my mouth, but that doesn't mean that they're wrong.
The same as the
the
time in
fact
your
that
table.
you
The
don't-
same as the ground being in the apple's future.
Yes,
The
yes.
same as all the other bullshit you say, Brenda.
It's not bullshit.
It's tiring.
This is standard physics.
bullshit.
This is
Brenda.
standard physics. We live in a four-dimensional world in which things follow on world lines, which is space-time world lines, and light is light comes in a quantum of energy.
No, not a packet anymore. It's a quantum.
That's what I said. Quantum and
So-
packet mean the same thing. Quantum means a
okay.
discrete unit. They mean the same thing. A quantum is a discrete unit of something. So light comes
Okay.
in discrete
So I
units
take-
of waves.
I take your word for this now, do I? You can't actually give a
look it up.
citation for this.
You do
Brenda,
the
you're
work.
one that's
Look it up.
You're
Look
the
up
one
the
that's
word.
made the claim, girl. You're the one that's made the
No,
claim.
I don't have to do
girlfriend.
your work for you.
No,
Look
but
up
you
the
have
word
made the
quantum.
claim. You have made the claim. Now provide the citation.
No, I don't have
That's
to.
all I'm asking.
I don't
Yes, you
have
do.
to.
You've made a positive claim, Brenda. If
No,
you
I don't
can't
have
cite
to.
If you can't cite your own claim, then your claim is just an opinion, and it is worthless.
It's not an opinion. This
It is an opinion
No,
unless
it's
you can
not.
cite it. Well, cite it
And that's
then.
all of physics. Any physics textbook
Brenda,
from
cite
the last
your
100
claim.
years.
Girlfriend, cite your claim.
I don't have to.
Yes, you made a positive claim. It is up to you to provide a citation to back your positive claim.
My citation.
So off you go, run along, put your
My
shoes on,
citation
go and
is
pick
all
your
of
apple
physics.
off the ground, go and get a pound of time and get a citation while you're out, love.
Time doesn't come in pounds. That doesn't mean it isn't physical.
Bev, are you back?
Yeah. I'm just looking at world lines. And,
Yeah.
Fantastic, aren't they?
Do you know that plumb
A
lines?
one-dimensional line or curve.
Yes.
I'm reading here.
Yeah.
Yeah.
So do you understand?
One-dimensional line or curve.
Yeah. So what?
Yeah. Do you have to imagine that one-dimensional line or curve?
It's a description.
Yeah. What's one-dimensional? I mean, I know what two-dimensional is. Can you explain a one-dimensional?
One-dimensional. That would be a line. It's a description.
Yeah.
It's geometry, right?
What, one dimension?
In geometry, lines are one-dimensional, right, Bev?
Yes.
Yeah, there you go.
And
what?
A one-dimensional line.
Lines are one-dimensional, Bev. Congratulations.
Yeah, two-dimensional line.
No, lines are not two-dimensional.
Well, you would be able to look at a two-dimensional line, wouldn't you?
There are no two-dimensional lines, Bev.
Are they not? Not even when you draw it?
Lines are not two-dimensional. They are one-dimensional.
Okay, in the concept.
Planes are two-dimensional, Bev. A plane is two-dimensional, a line is one-dimensional, and a point has no dimension.
Length without breadth, right?
Yeah.
Geometric term for a line.
That's geometry. You understand?
Yeah. Yeah, so yes. A one-dimensional line or curve is what a world line is.
Yeah.
Yeah. Okay, so that is what you were using to explain four dimensions?
No, it explains. It's part. It's part of relativity theory.
Yeah.
Yeah, it's part of the theory.
That where you use a one-dimensional line to express a four-dimensional time frame.
No. You got that wrong.
Okay, so go on. What's a world line then?
A world line is a one-dimensional line. It's a description. It's a description of an object's motion through space-time.
Okay, these we are talking world lines in special relativity, right?
Yeah.
Okay. And then what I'll do is
it's a description, right?
Right.
Do you understand what a description is?
Yeah. Okay, here you go.
Right. So it's a
I've
description.
marked out a few bits there so everyone can see what world lines in special relativity. And it says world lines or freely falling particles / objects are called geodesics in special relativity. These are straight lines in Minkowski space. Do you want me to show you what Minkowski space looks like?
Yes. And Minkowski space is curved space-time.
But it's what Minkowski space is. You know how it's shown Minkowski space. I get that. So just for anyone who doesn't.
So you're just backing up everything I've said for the last half hour, right? That world lines, objects are following a geodesic in four-dimensional space-time.
Yeah, a geodesic, which is a straight line depicted on a graph, just like that.
Yeah.
Minkowski.
Yeah.
So they represent 4 dimensions on a 2-dimensional graph with a straight line that is actually 1-dimensional.
What about it?
Well, I was just in case anybody didn't understand. Does that explain it to everybody better than what Brenda's done?
What you're showing is the world line of a photon. The world line of a photon is a 45-degree angle on a Minkowski diagram.
Yeah, how is it?
Nothing else can follow. Nothing else, because we can't travel at the speed of light, so our angle would be less than that.
Properties of space and time in a special theory.
Yeah, everything. Thank you for backing up everything I've said. Objects follow world lines, which are geodesics, as described on a four-dimensional space-time Minkowski space. That's everything I've been saying over and
Are
over. Thank you for backing me up. Thank you for backing me up, Bev. Thanks.
Event as happening in a universe consisting of one space dimension and one time dimension.
You can do that.
That's what Minowski
You can
graph
do that.
does.
You can do that.
Yeah.
Yeah, they just collapse the space dimensions into one axis, and the time dimension is the other axis. Photons, in that kind of a diagram, photons travel at the speed of light, which is that 45-degree angle that you see there. We can't travel at the speed of light.
Yeah, that's fine.
Thank you for backing me up.
Two-dimensional graph to show a one-dimensional line to explain a four-dimensional space-time.
You just collapse
thing.
You just
collapse
place in a theoretical universe.
This is a description.
Absolutely ridiculous.
The universe isn't theoretical. The description is theory.
To you,
yours
is a belief
it's
system.
imaginary. It's in your head.
No, it's not imaginary. It's not imaginary.
It's a belief system. It's a belief system, Brenda.
No, it's a theory. It's a scientific theory. A scientific theory is not a belief system.
You live in a belief system.
No, I don't. I live in reality.
You believe you live in four-dimensional space-time continuum.
This is a description of the reality that we live in.
Oh, the reality you think you live in, Brenda.
Well, it's not a belief. This is how reality is.
Well, I see. We deal a lot more in reality around here.
You don't understand parallel lines, Bev.
Brenda, you can't say that he doesn't understand. You can't claim that anybody doesn't understand.
Yes, I can.
Because you don't know.
DP,
yes, I can.
Brenda's going to explain it.
She's going to explain it.
Yeah.
Really?
I'm going to explain that Bev doesn't understand that plumb lines are not parallel.
Why? How?
Because you can measure them, and they're not parallel.
How would you do that, Brenda?
You would measure them.
How? How would you measure them? Tell me, please.
You would make a series of observations. You would construct two plumb lines a certain distance apart, and then you would measure them to see if they are parallel. And as it turns out, they're not.
Explain the measuring process, please.
I don't know. You just go about doing it. It doesn't matter.
You're spouting words again.
It doesn't
matter. I've got one for you. Brenda, I've got one for you. How far apart do those two plumb lines have to be before they actually start showing a divergence from plumb? And is the divergence from plumb divergence from each other, or is it divergence from a central plumb line, a third plumb line, essentially, that you'd have to put in to measure the divergence from?
The reason is that plumb lines
I didn't ask for a reason.
Point to the center. Plumb lines point to the center of the Earth, and therefore they are radial. They are a radius, and they point to the center of the Earth. So therefore, they're not parallel.
Believe reason. I asked at what point does this divergence become a measurable, tangible, observable thing?
It depends on your ability to measure it.
Well, Brenda, there must be a certain.
It depends on your equipment.
Well, what equipment are you using to measure your make-believe divergence of plumb lines?
I don't make the measurements. I'm not a surveyor, but surveyors do, and they can.
But you spout their rhetoric.
Bev was in a hangout with MC Toon, and MC Toon humiliated Bev and showed him how wrong he was.
No, he did not. MC Toon spouted the same bullshit rhetoric that all of you do.
It's not rhetoric. These are facts.
It is rhetoric.
These are facts.
You all sing from the same hymn.
He humiliated you. He humiliated you and showed you to be the utter fool that you are. That you can't understand the difference between plumb and parallel.
Brenda, if you can't have a decent conversation without
I just want to be able to finish a sentence. You constantly interrupt me. So why should I respect you? Yes, you don't care.
Well,
then this is what happens when you don't care.
It's not me you're disrespecting. It's Bev.
I'm disrespecting you because you just constantly interrupt me. That's
Brenda,
all
can
you've
I just
done.
put in here?
That's because I've got no respect for you,
DP.
Brenda.
Let's
Sorry,
have a go at
Bev.
this. Brenda,
Right.
you say surveyors have measured this. Can you name a surveyor, please?
I posted the link.
Put a name to that person, please, and then we'll look into it. I mean, but I need to know who you are getting your information from that says they have measured plumb lines, because you obviously don't know how to do it or anything. You don't know the method or whatever. So you're obviously not really good. You're just getting this information from someone. Now, who has told you that they have measured that plumb lines are not parallel?
There you go. There's the link to the main surveyor.
Right. So him,
and he shows that plumb lines are not parallel.
And you personally are willing to take on what this person says. Yes. You are saying that this man has definitely done what you've just claimed he has done. Yes? Or he's just made a video. What you doing? Which one is it, Brenda? I know he's made a video.
There's the slide. There's the slide from his video, the measurements.
Yeah, that's great, isn't it? Who have you been over and checked this out with?
Yeah, do you understand what that's talking about? It shows
have you been to a team meeting and made sure that that's okay?
It shows that plumb lines are not parallel, and this is a real world measurement.
That picture does, doesn't it?
Yeah, picture.
No, the picture is an illustration. The picture is an illustration of what he did, what was done.
Brenda, so you have belief.
Really? That is an illustration of what this man did. Yes? You've watched the video and you know for sure that this is an illustration of exactly what that man did.
So do you have a problem with that? Do you have a problem with this? What is your objection? What is your objection?
I'm just trying to make sure, Brenda.
What's your objection?
Just trying to make sure.
What's your objection?
Okay with this? I'll go over it in a video.
What's your objection to it?
You can't see a problem with it.
No, I don't. What's your problem with it?
That's fine.
What's your problem with it?
You don't have it. But I mean,
what? Well, you can think it's hilarious, but what is your problem with it?
What? Hey, what?
What's your problem with it?
Can you see that bit in the middle?
Yes.
Them two dotted lines. What are they?
The two dotted lines are horizontal line A and horizontal line B.
Okay, and then imagine you've got plumb line A and plumb line B. Yes?
Yeah.
Right, okay. Now, is the plumb line at B perpendicular to the horizontal at A?
No, it's perpendicular to the horizontal
vertical
at B.
And horizontal aren't perpendicular then, are they not?
The plumb line is perpendicular to the horizontal line at B.
Mm-hmm.
It's perpendicular, right?
But it's not perpendicular to the horizontal A.
That's correct. That's the point. They're not parallel, are they?
Okay, so how many plumb lines could you put on a horizontal?
So they're not parallel. The point is that they're not parallel, are they?
Can we count them, Brenda? You tell me when to stop.
Bev.
1, 2.
Bev.
Ooh, 3. I got past 2.
Is the plumb line? Is the horizontal line at the plumb line at B? Is it perpendicular to the horizontal line A?
It should be, yes.
But
it
doesn't
appear to be on that drawing. Well, it's not on that drawing.
Yeah, it's not. But the drawing represents
drawing.
The drawing represents real world measurements. That's the real world. Yes.
And that was done. That was definitely done by the main surveyor.
Yes, and that shows that they were not parallel. Right.
Right. So that shows that when people say vertical and horizontal are perpendicular, there should be a proviso that comes after that says only at one point.
Yeah, that's what it means.
No, it's not.
That's what perpendicular means.
It's
perpendicular
really
means
no,
it's perpendicular at a point.
You would really, really struggle with Euclidean geometry. Fundamentally,
no, I don't struggle with it at all.
What you are trying to explain. I can
don't
understand why
struggle
you
with it at all.
struggle mentally trying to understand the concept of reality.
You're the one who can't understand this. Bev, the plumb line at B is perpendicular to the horizontal line at B, right? And the plumb line at A...
A horizontal and a vertical are perpendicular to each other. That's why they're just called perpendiculars, aren't they?
Well, at B.
Well, no, the horizontal and vertical are perpendicular.
At A, it's a different horizontal and a different perpendicular.
It says that at A is a proviso.
That's exactly
anywhere.
what it says. That's exactly what it says.
Should I have a look?
At station A, it says that there's a plumb line and a horizontal line, and they are in perpendicular relation to each other, right?
Yeah, horizontal and vertical are definitely perpendicular.
At occupy station A.
At all times, yes.
No, at position A and at position B, there are two different horizontals and two different perpendiculars.
What, have you got any citations or anything?
This is the real world. This is how it works.
Just what you say is the real world.
No, this is a real world measurement. This is a real world measurement.
What is a real world measurement, Brenda? You don't even know what measurement they've done, do you? You don't even know the method that
this is a real world measurement.
And what is the real world measurement you are talking about?
At A, there's a plumb line and a perpendicular, which is perpendicular to horizontal line A, and at station B, there's a plumb line which is perpendicular to horizontal line B, right? And they are different. Therefore, they are not parallel.
They are not parallel.
Correct.
And
they're both plumb lines, and they're not parallel.
Can you explain that geometrically?
I just did.
Really?
You have two plumb lines. You have two plumb lines at two different stations, station A, station B. You construct a plumb line, and that they are perpendicular to horizontal line B and horizontal line A, and they are different. They are not parallel. This is the real world, the world we live in, on Earth.
Yeah, where horizontal is a straight line.
Horizontal is a straight line perpendicular to the plumb line at point station B, at that point. But it's a different horizontal line at station A. It's a different horizontal.
Yeah, which would eventually intersect with a horizontal. Is that what horizontals do in your imaginary? Like, have you ever drawn a graph with an X and a Y axis?
This is on the real world. This is not on a graph.
Well,
this is the real world.
We use Cartesian coordinates to express coordinates in reality, don't we? Or do you not?
You can use spherical. You use spherical coordinates on a planet.
Will you? Really?
Yes.
Spherical coordinates. Can you give us an example of one of them for us, please?
You're the geometry guy. You don't know what spherical coordinates are?
Oh, why would I want to know what spherical coordinates are?
Because you live on a planet.
Says who?
It says reality.
Right, well, isn't that what we're trying to do here, though? We're trying to decide. You've already decided, have you?
Because if we lived on a plane, then plumb lines would be parallel. Plumb lines are not parallel, so we do not live on a plane.
Plumb lines are perpendicular to horizontal, aren't they?
It doesn't matter. If we lived on a plane, the plumb lines would be parallel. The plumb lines are not. The plumb lines are not parallel. The plumb lines are not parallel. Therefore, we do not live on a plane.
Saying it.
Yes, because you don't understand it.
You learnt that from Rumpus.
You don't understand it.
You say you don't understand that. Did you learn that from Rumpus, or was that somebody else that taught you how to do that one?
So, do you now understand that plumb lines
vertical and horizontal are perpendicular? Yes, I do. Fine.
There's a perpendicular.
Nice,
the plumb line is perpendicular to horizontal line B at station B, and it's perpendicular to horizontal line A at station A, but they are different perpendiculars, and they don't intersect. I mean, they're not at right angles with each other. They are at 94. They're 94 degrees,
always.
4 seconds, right?
Yeah, vertical and horizontal aren't always perpendicular. Is that? Do we need a new definition for vertical and horizontal?
No, we don't.
Well,
no, we don't.
So all of these ones that say in the dictionary or anywhere, it says perpendicular, and then approximately right angles to the horizon. That's vertical, obviously. Perpendicular and plumb are generally used to specify an angle of precisely 90 degrees.
Yeah. That's what the image shows.
Yeah, and perpendicular needs two straight lines, doesn't it?
That image shows.
Yeah,
that
can I get a confirmation on that? Yeah, perpendicular is two straight lines, isn't it, Brenda?
No, perpendicular is a 90 degree. No, perpendicular is a 90 degree angle to a defined point.
Yeah, and all right angles are equal, right? All right angles are equal.
Yes, and yet these right angles don't add up. They don't add up.
They don't. Sorry.
They don't add up.
Who doesn't add up?
They are greater than 180 degrees.
So is that a straight line has more than 180 degrees?
So the sum of the angles A and B is greater than 180
some
degrees.
Some of the internal angles of the triangles within he's just done there is greater than 180 degrees.
No, of the plumb lines, the angles A and B add up to be greater than 180 degrees.
Okay, so the triangles there have an internal angles of 180 degrees.
That's not what I'm talking about.
It is, isn't it?
No, it's not what I'm talking about.
No, yeah, of course it is.
We're talking about the angles A and B in the illustration I posted. The angle B at station B and the angle A at station A is greater than 90 degrees. They add up to more than 180 degrees. If they were parallel, they would equal exactly 180 degrees. Therefore, they're not parallel.
Brilliant. So, your basis of all of this relies on the fact that some dude has done a video on YouTube that you cite saying he has actually measured more than 180 degree internal angles on a triangle.
No, it's not based on some dude. It's not based on some dude. This is
you just posted it before. The main surveyor was your dude, your man.
Yeah, that's an example. It's not just some dude. It's
you've had a word though, haven't you, with him? And he's told you this is rock solid, Brenda. Absolutely rock solid. This
is all engineering. Right? This is all surveying. Right. All engineers, all surveyors.
Is it all surveying?
Yes.
Not plane surveying, surely.
Oh, no, yes,
plane surveyors. All of them. Plane surveyors assume a flat plane, don't they?
So this is at all observers will record that if you construct a plumb line at one point and another plumb line at another point, then the internal angles of those plumb lines will be greater than 180 degrees because they are not parallel.
Okay, so what sort of a distance do you reckon he did measured that at?
Well, it doesn't matter what the different distance is.
It does, because
No, it doesn't. It doesn't matter.
Brenda, yes.
It doesn't matter.
Listen. we're trying to measure a water level test. Now, the
No,
water
we're not.
level.
We're not
yes,
trying
we
to
are.
measure.
This is-
No, we're
right,
not.
Yeah, we are.
No, we're not.
We are, Brenda. We are laying off a horizontal baseline. We're calling that the water
No,
level.
we're not. No, we're
Right?
not doing
Then-
that. That's not what we're doing.
Then we can get 2 theodolites or levels or dumpies or whatever. I've got one. Spot on's got one. We can meet at the side of the canal. We can get a water level there, right? Now, you say that the horizontals that both our tools have will not sight each other, right?
Yes, I'm
you
saying
say they will sight above each other. Now,
I'm saying
what sort of distance could we get in order to measure that distance?
it depends on your equipment, on how accurate.
Like when I say measure, I mean actually measure with a stick to measure, right? Not just messing about with angles and
It depends.
some
It
sort of,
depends on your equipment, right? It would depend on how accurate your equipment is. Over a greater
Yeah.
distance, you would
Okay,
require
let's say
less
we've got
accuracy.
the best equipment.
I don't
how far
know.
apart would we need?
It doesn't
do that,
matter.
Brenda?
It doesn't matter.
It does.
No,
Yes,
it
does.
doesn't. It
It
doesn't
does
matter.
because you're talking bollocks.
No, I'm not.
Yes, you are. You're definitely
No, I'm
talking
not. This is
absolute shite.
Bev. This is
Yeah.
this is how things actually are. When you
It's
have,
not.
if you have 2 points,
It's
if
no
you-
good. Just saying that is not convincing yourself, and you are definitely
this is not just saying
convincing
things.
anyone else here listening.
well, my
Right?
inability to
You
convince
do not know the first thing about surveying, right?
It doesn't
now, you
matter.
are claiming that professionals
it doesn't matter.
that do a job that you know nothing about
It doesn't matter.
do something that you also know nothing about.
None of that
And
matters.
yet, you are claiming you know everything about it.
No, I'm claiming.
Isn't that strange, Brenda?
I'm not claiming to know everything about surveying. I am claiming that when you construct a plumb line at 2 different points, those plumb lines will not be parallel. That's all I'm claiming.
You are claiming that because you've watched a video. Did you? I don't think you may have read the title of a video that somebody's made. And now
It
that
doesn't
man,
matter.
that man takes a very good topic, like, and he goes, I tell you what, I'm going to call myself. I'm not going to be a professor. I'm going to be a surveyor. So this character
this is
makes
all
a
besides the point.
pretend, doesn't he, Brenda?
This is all besides the point. If you construct,
you know the acting game that goes
if you
on
construct,
on the
if you-
YouTube.
if you construct a plumb line at 2 different points, those plumb lines will not be parallel on Earth.
Says Jeff, the main surveyor.
Says all surveyors and all engineers.
I wouldn't. Don't
all
jump
observers.
everybody into it.
Yes, all observers will make the
So
same measurement.
you are making a claim. Yes,
on Earth.
Brenda, definitely.
Yes. Listen, stop interrupting me. Stop talking over me. All
That was rude.
observers on Earth will show or be able to measure that 2 different plumb lines at 2 different points will not be parallel.
Okay. So my water level test will definitely show that the water level rises in between the 2 bits, right? Because the horizontals rise to that point, so we'll definitely be able to show that with my water level test.
I
now,
don't know.
Nick earlier said that. No, you've just said it. You
No, I
don't
don't know.
realise what you're saying.
No,
but you
that's
have just
not
said
true.
that geometrically. Yes, you have.
No, I haven't said that.
Yeah, you
I
have,
don't know.
Brenda.
Your
You
water level test might not be accurate enough.
Over 2 miles.
You've done this 2-mile water level test?
I know.
You haven't done
We're
it.
just
You
trying
haven't
to,
done it.
We're trying to work through. No. So what would it prove then, Brenda? What would happen? What would
You
we
haven't done
expect to
it.
see?
You haven't done it.
What would we
The
expect
water
to
le-
see? How high would the hump in the middle be?
There's no hump in the middle.
It's horizontal then. Thanks.
No, there's no. It's not horizontal. The Earth is curved.
Okay.
You're a
so-
flat
but there's
earther,
no-
and you
there's
think
no,
you think that there's
no
a
hump in the middle of a curve.
Right.
Yeah,
right.
yeah.
There isn't.
Yeah.
Not on a
There isn't.
globe.
On a curve.
Not on a globe.
On a
Yeah.
curve.
There's no hump
It's
in the
flat.
middle. It's not
that's
flat.
horizontal.
It's curved.
We'll call it horizontal, should we?
It's
Should we
not
call
flat.
it horizontal? Should we call it horizontal?
It's not
just
flat.
imagine it curves.
Do you understand how spheres work?
Yeah, they have a big curve in them.
If I'm at the top of a sphere of a ball, and another person
balancing it. You're good at that. Circus act.
Just a minute. Just a minute.
Can you do juggling? I can imagine.
Try not to get distracted.
Don't
get distracted by the shiny object. Don't get distracted by the shiny object. If you are standing at the top, if you're standing at the top of a sphere, right, and somebody else is standing a ways away from you, is there a hump in the middle?
Sorry.
Yeah, I know.
I'm imagining you rolling about on a ball.
Yeah, you got distracted by the shiny object. So if you are standing on a large sphere, right, and somebody else is standing a ways away from you, is there a hump?
Do they have their own sphere that they're standing on?
No, they're standing on the same one you are. Is there a hump?
What? How could they be standing a ways away from me?
Is there a hump?
Roll off, wouldn't we? Like,
is there a hump?
Have to be really close, balancing together.
Is there a hump?
What?
Is there a hump?
I don't know. You'd have to show me what this looks like. I can't imagine how you
can't imagine
stand on a ball with somebody else.
Right. You can't imagine standing
and not
on
fall
a sphere.
Off, that'd be a...
Yeah, you can't imagine standing on a
sphere. I can imagine you standing on a sphere.
Can you imagine you standing on a sphere?
Balancing like you, juggling.
It's a really large one. It's really large. It's huge. You don't have to juggle.
Oh, right.
You don't have to
You'd have to be on the top, though, wouldn't you? Because it's a ball. You'd still have to balance, wouldn't you?
Yeah, but somebody
it would
else
roll about all over the place.
If it's really big, somebody could stand a ways away from you without falling off. It's really big.
It would roll, wouldn't it?
No,
yeah,
they
but
wouldn't.
It's a ball. It'd roll, wouldn't it?
No, it's a really big.
That's what balls do, though. It doesn't matter how big it is. If you put a uneven weight balance on one side of it, it'll roll that way, won't it?
Imagine yourself on a sphere.
Imagine.
Yes.
Yeah.
Try.
I'm trying to imagine it.
Can you do that?
Falling off. If you move me away from this, the top of it, I'll fall off.
Can you do that?
It will roll.
Why are you avoiding this?
Like log rolling or something like that.
Why are you avoiding this?
Spot on. Why am I avoiding what, Brenda?
Why are you avoiding this?
Why am I avoiding what, Brenda?
Yes, like this right now, what you're doing right now. Why are you avoiding it?
Yeah,
why are you avoiding?
Tactic, isn't it? Like, I'm sure you look really smart at this point.
Why are you avoiding?
What am I avoiding, Brenda?
The illustration.
Which illustration? Have you put an illustration?
What I was talking about, imagining yourself on a sphere.
Did you illustrate that imagination?
Why are you avoiding this now? You're doing it again.
I'm looking for it.
You're looking for what? Just
the
imagine yourself. Just imagine yourself on a sphere.
Yes.
Okay. Imagine somebody else a bit of a ways away from you on a sphere.
That I can't. Like, that's
you
really
can't do
tricky,
that.
We're
can't
not
do that.
Circus for the acts.
You can't do that, huh?
Balance. I'd have to get it really. You have to practice that.
Why are you pretending to not be able to do this?
I'm living in reality, Brenda.
That's
a pretty circus trick, that.
No, it's not reality. I asked you to imagine yourself.
It's not reality.
Right. I asked you to imagine yourself on a sphere. That's not reality.
Yeah. And I'm telling you that if you move away from the center balance point, then the sphere will start rolling.
No, this is imagination. It's not real.
Yes.
Right.
Okay, so is it fixed then? Is this ball fixed?
Just imagine yourself on a very large sphere.
And the sphere isn't going to roll. It's fixed.
No, it's not going to roll.
Okay. So the further I walk away from that top point, the
you're
more
just standing on it. You're not moving.
Turn like into a slide.
You're not moving.
Okay, I'm right at the top of the sphere. Stood on it.
Yeah. half an hour to get you to imagine this. Half an hour.
No, I've been looking at it all the time. I'm still imagining it now.
No,
I'm
you
a
can't-
sphere. I'm stuck,
Right.
sat on a sphere.
So
It
is there a
doesn't move,
hump?
It's not going to roll anywhere.
Is there a hump between you and somebody else on the sphere, or does the sphere fall away from you at every point? Does it fall
like
away
a
from you?
slide, isn't it? Or yeah, it's like a
Yeah.
slide. You could slide off it.
Right. There's no
Yeah.
hump, is there? There's no hump.
What do you mean? There's no hump?
You're the one that said there was
It's like
a hump.
big, massive curved surface all around me.
Yeah, but there's no hump, is there?
Brenda, what are you talking about?
I'm talking about the hump. Where is the hump?
The camel?
No, the hump. You said there was a hump. Where is it?
One hump or two.
In the water level. Yeah,
Where's the
remember
hump?
that's what we're talking about here.
No,
water
we're not.
Level.
That's
if
not
there's
what
no
we're talking
hump,
about.
It's horizontal. That's what the water level does. It finds its
So-
own equilibrium. So it's all the same level.
So you said there was a hump. Where's the hump?
You said there was a hump because you
No,
had
I didn't.
intersecting horizontals.
No, I didn't.
Didn't you?
No,
yes, you
I
did.
didn't. No, I
yes,
didn't.
you did. You showed us a picture of it, Brenda. You showed us a picture and said the main surveyor, Jeff, has measured parallels.
Plumb
Plumb
lines.
lines are not parallel.
Correct.
And the reason he's done that is because the horizontals intersected at a point. Now that
That's not
point
the reason.
is higher than both of the other two horizontals start point.
Yeah.
Yeah. So
Which
you have
shows-
said there is a raise in between the two horizontals.
No, it doesn't show that.
It does geometrically. It shows it. You drew
No,
the
it
line,
doesn't.
and they intersected there. That point of intersection was not on the line, was it, Brenda?
It's
So
not on
you have confused. You have confused everyone by saying that horizontals intersect,
but they
which
do.
they obviously do not.
But they do.
They can't, can they?
But they do.
Really?
Yes, they do. You say they can't,
Because
but they still do. Because
You
that's
say they
because
just have to.
no,
They
not
just
because
have to.
not because they just have to, but because on a spherical Earth, plumb lines are not parallel. That's why they intersect.
Can we say
above
in
the straight line.
reality? Do you want to try in reality?
In reality, on Earth, plumb lines are not parallel, and a horizontal from station A and from station B will intersect above line of sight.
How much practical use of geometry have you ever had? Ever?
What
I'm
does that have
talking.
to do with anything?
Have you ever used a level? A site level,
a carpenter's
theodolite level?
A carpenter's
Well,
level, yes.
Oh, you have used the carpenter's level. Any other? Have you ever used
No.
a water level?
No.
No. Okay. You've used the spirit level, though.
What does that have to do with this? Plumb
I'm
lines.
just checking
plumb lines.
your practical. Have you ever used a plumb line?
No.
plumb bob.
Well, yes, I've used plumb lines. Yes.
Okay. What was it to do?
It was when I helped my family. We built a house, and we used plumb lines and carpenter's levels to construct the house.
You used the levels to construct the house.
We used the levels in the course of constructing the house. Yes.
Okay. How did you use the plumb bob? Just as a matter of, when
To make sure the concrete was level.
The concrete.
The concrete and then the walls. Yes.
Okay. So you used the plumb bob to make sure
They're
the
vertical.
concrete was
they
level.
were to make sure they were vertical. Yes.
Okay, the concrete.
To make sure
Yeah.
the walls were vertical.
Oh right. Where was the concrete? Did you have concrete walls?
No, we had a concrete floor.
So you used the plumb bob to make sure the concrete was level?
To make sure the walls were level.
Oh, no, not the concrete.
The walls were vertical, I'm sorry.
Okay. Yeah, it's a good job you had vertical walls.
Yeah.
So what did you use to make sure the concrete was level then?
A carpenter's level.
Really?
Yeah, you just flatten it out.
You didn't level the shuttering beforehand?
It didn't level what?
The shuttering for your concrete work.
I don't know what you mean. We had people come in and pour the floor.
Oh.
What does this have to do?
So you didn't actually use the plumb bob then, or any of these tools?
So what does this have to do with anything? This is a nice distract. This is one of your
So when
tactics.
you said you'd actually use them tools, you were just lying.
This is a
Somebody else
distract.
used it. You watched,
what does this have to do?
somebody else use it.
This is one of your tactics, is to distract.
To distract from knowing
From
how
knowing
much
that
validity you have in what you're talking about.
No, to knowing that plumb lines are not parallel.
Well, so far you know it because you've watched a man on thingy.
No,
before,
I know it because I understand. I know it because I understand how the world works. Right.
So before you watch this video, you already knew that plumb lines cannot be parallel. There are no two on your model. Of
yes,
course.
I knew that. I knew that before the video. Yes, because I understand
so geometrically.
Right.
Did you understand geometrically that beforehand, vertical and horizontal being perpendicular was going to be a bit of a problem?
I knew because I know that there's such a thing as gravity, and that plumb lines point to the center of the Earth, and therefore plumb lines at different points on the Earth will not be parallel. They will be radial from the center of the Earth. It's simple geometry.
Yeah. It doesn't seem to be mentioned anywhere anything about vertical, that though, does it?
It's simple geometry.
Anywhere? Have you got any source anywhere, Brenda, that says
I don't need a source.
Vertical being to the center of anything, please.
I said plumb lines.
Yeah.
Plumb lines.
What's a plumb line for?
Plumb lines point.
What's a plumb line do?
Stop interrupting me. Plumb lines point to the center of the Earth because of gravity.
What are plumb lines, Brenda?
A plumb line is a line, a string with a weight on the end.
Yeah.
Right?
That establishes a vertical frame of reference, right?
It points to the center of the Earth, right?
It's not vertical then. Do you not think it's vertical?
Vertical is a direction straight from the center of the Earth. That's what vertical is.
Perpendicular to horizontal vertical, Brenda?
No. Plumb lines point to the center of the Earth.
I don't think so. I don't think anywhere it says center.
Yeah, plumb lines point to the center of Earth because that's how gravity works.
Is that geometrical term? Is it?
A center is a geometrical term.
Perpendicular to horizontal, Brenda. This is getting a bit boring, but I mean, I don't know. Are you trying to convince people that vertical isn't perpendicular to horizontal? No. Is that what you're saying?
Plumb lines are vertical. They're vertical because they point towards the center of the Earth.
Oh, they are vertical because they point to the center of the Earth, but they're also perpendicular to horizontal.
So a plumb line in North America. Just a minute. Listen to me. Try to listen, and please allow me to finish my sentence. A plumb line constructed in North America will point in a completely opposite direction from a plumb line constructed in Australia.
Can I give you one example? Right now, I will go and stand at the North Pole, supposedly, with Polaris at my zenith. Okay? You understand that? And so that is my vertical is pointing straight up.
Do you understand that a plumb line in North America?
You can go to Ecuador, right? And then you stand and you have your vertical pointing up.
Yeah, and they will point in opposite in different directions.
So, yeah, would you be able to say quite confidently that my vertical was perpendicular to your vertical?
No, your vertical would be perpendicular to the point at which you are. And my plumb line in Ecuador will be perpendicular to the point where I'm at.
Yeah, but would you think that my vertical and your vertical would be perpendicular to each other?
Why would I think they're perpendicular? You mean parallel? I think you meant parallel.
Well, no. Like, listen, on your model...
You meant parallel. You must have meant parallel, right?
On your model, I'm stood at the North Pole. Yes.
So all of a sudden you can imagine yourself on a sphere, right?
I'm just
all
checking with you.
All that stuff that half an hour before that was you
Brenda,
just pulling bullshit, right?
You just said before, right, that they would be parallel.
So all of a sudden you can imagine yourself on a sphere,
how
right?
Can you imagine that two verticals are parallel?
They're not. They wouldn't be parallel.
You weren't thinking when you said that, were you?
They wouldn't be parallel, would they?
No.
The vertical in Ecuador,
would be for me.
No, they wouldn't be. No. In reality,
on your model.
In reality, they would not be parallel.
Yeah, they would. Of course they would.
No, they wouldn't.
Right. So on your model, I'm at the North Pole with Polaris at my
which
zenith.
you're suddenly able to imagine yourself at the top of the sphere. Yes.
That you would imagine that's at the top of a sphere. Okay.
Yeah.
And then you are at Ecuador.
Yes.
And you have a vertical.
Yes, and my vertical points in an entirely different direction than yours.
What angular difference would there be between my vertical on your model and your vertical on your model?
I don't know what the degrees would be. That would be measured in degrees, right? The angular difference is measured in degrees.
An angle would, yes. Yeah.
Angular differences are measured in degrees. I don't know how many degrees difference that would be.
Right, but you are imagining there would be a difference between my vertical and your vertical.
Yeah, they would be different.
Yes, that's okay.
Yeah, that's reality. That's how it actually works.
And that's because you can say that confidently because
yes, I can.
You've seen a title of a YouTube video that says that.
No, that's not why.
Oh. Okay, but that was what you give up as your proof.
No, that's not proof. It's my example.
Okay.
It's a demonstration.
So your proof is?
My demonstration is based.
Yeah, well, your proof of this fact is
that's what we observe in reality, is that plumb lines are not parallel.
But you just admitted before you've never used a plumb line.
No, I said I had.
How do you know that it is observed, that it happens?
Because I understand how reality works.
Oh. You definitely sure. And your understanding stretches to geometry to understand angles and measurements of things. Okay,
yes.
So you definitely understand geometry.
And
gravity. You definitely understand perpendiculars.
And gravity.
And the fact that angles need two straight lines to be measured.
And gravity. I understand gravity.
Works in the vertical direction.
No, gravity establishes verticals.
Oh, brilliant. That's even better. Which is perpendicular to horizontal.
No.
Vertical is perpendicular to horizontal, isn't it?
No. Gravity establishes what is vertical locally.
Yeah. Which is perpendicular to horizontal.
So the vertical at the North Pole is entirely different than what's vertical in Ecuador. They're two different directions because of gravity. Gravity is what establishes what is vertical.
Well, yes, but only if you imagine you live on a ball with them two verticals be different.
Right.
You have to imagine you live on something in order to imagine that verticals aren't perpendicular to horizontal.
But then if we measure them and they are not parallel, then we know that the Earth is curved. Because they're not
brilliant.
Parallel.
So it will definitely have been measured by somebody who knows what with the most accurate results possible, right?
It says done all the time by engineers, civil engineers, surveyors, all the time. Buildings,
brilliant.
Buildings and the supports for bridges point in different directions, all the time.
Yeah.
Yeah, you're not being able to understand it. Doesn't mean it's ridiculous. So if the Earth is flat, then plumb lines would be parallel. We observe and measure that they are not parallel. Therefore, the Earth is not flat.
And Jeff, the main surveyor, is your main man.
No.
Step up.
I just told you.
Jeff.
I just told you. No, he's not the main man. He's just one example among many.
Okay.
I could cite another would be people have measured. There are these very long bridges. They're very long bridges.
No, Brenda.
There are very long bridges.
Brenda,
there are very long bridges.
That you do not know a thing about what you're talking about. I would prefer if you said another name and then I can start asking them, because it's obvious that you don't know what you're talking about.
It's obvious I don't know what I'm talking about.
Yeah,
but you
because
confirmed
you've never
everything I
touched
said.
a plumb bob or a level.
It doesn't matter.
You've just watched people hold
Let's say what you say is true. I have. It's not true, but let's say it's not. It is true. I've never touched a level. I've never touched a plumb bob. Let's say that's true. It's not true, but let's assume that it is. What difference does it make? What difference does it make, Bev?
Difference. Does
What
it make
difference
that
does
you're talking about something that you've never even practically done, as though you are an expert in it?
No, let's say that's true. Again, I have touched levels. I have touched plumb bobs. But let's say it's true. I have no experience with these things. So what? What does that mean?
So you are talking about it as though you are an expert and you know all about this.
I'm talking about... No, I'm not talking about it as if I'm an expert. I'm talking about it...
You are, but you are just saying that you deny Euclidean geometry. You say that surveyors do not measure levels because they have somehow a wandering horizontal that has to be checked every time they move their level. Every time, Brenda. Every time.
Bev, I'm not denying Euclidean geometry.
Yes, you are. You may not realize you are, but you are.
No, you don't understand Euclidean geometry at all.
Well, that's obvious, isn't it? Because saying
yes, it is. Everybody understands that you don't understand these things.
Everybody understands that I don't understand it.
Correct.
Right. Okay. So you would know all about Euclidean geometry, wouldn't you?
So the point is that I don't have to have used a level or a plumb bob or a theodolite. I don't have to know anything about those.
No, you can imagine whatever you want, Brenda. Everyone knows that.
I don't have to have used those things to understand. To understand conceptually what's going on.
Really?
Really?
Yeah. How much have you ever looked at into surveying?
Little to nothing.
Well, there you go. So how can you just imagine that you know all about it, and when you are especially imagining some sort of curve that you can't even geometrically describe?
I did, and I don't have to know everything about surveying.
How did you
Could you not interrupt me, please?
Because you just said I did.
Could you? No, I don't have to know everything about surveying to understand. Could you stop interrupting me, please? Could you stop?
Curve.
Could you stop interrupting me? Please allow me to finish a sentence.
Okay, I want to hear at the end of this how you geometrically describe the curve that you speak of.
I'm going to tell you that I don't have to know everything about theodolites and land surveying to understand the basic concepts involved.
It's not concepts, is it? Reality.
Yeah, no, it is. It's concepts. The concept of vertical.
Surveyors survey the land practically. Don't tell them it's a concept. People do this for a job, Brenda. You know nothing about it.
It doesn't matter.
People's careers.
I'm not rubbishing their careers. You are.
You are saying that they do phenomenal things.
I'm saying that
You are claiming that, Brenda.
I am saying that I don't have to be a surveyor or to understand theodolites to know and understand the basic concepts that we're talking about, that plumb lines are not parallel.
So the concepts are there are plane surveyors that use tools. You know that, don't you?
That's not the concept. That's not the concept we're talking about.
There are plane surveyors. You know that there are plane surveyors, right? And every surveyor you see with a tool, a theodolite, a level, a water level, anything, measuring tape, a measuring angle device, anyone that you see of that, they will be using Euclidean geometry. Now, in Euclidean geometry, triangles have 180 degrees internal angles. Right, Brenda? And horizontals are parallel.
On a sphere,
as
on a sphere,
verticals. Plane surveyors survey using Euclidean geometry on a plane.
On a sphere, verticals are not parallel.
Yes. But there are no such things as verticals on the sphere as you imagine them.
The verticals are established by the force of gravity, which pulls the plumb bob straight to the center of the Earth.
On every sphere?
On a sphere, yes.
Every sphere has its own gravity and its own verticals.
Yes.
Is that true, Brenda?
Every large, massive planet has its own verticals, yes.
Right, so you could show me that on any sphere, couldn't you? You could explain how... No?
No.
So when we look at a sphere, verticals at the top. Yeah?
It isn't the sphere which makes things vertical. It's the gravity.
And that acts vertically, which is perpendicular to horizontal?
Gravity doesn't act vertically. Gravity pulls things towards its center,
gravity,
which establishes...
It's an effect. It's an effect.
Gravity determines what is vertical.
The effect determines what is vertical.
Gravity pulls the plumb bob, the plumb at the end of the line. Yes.
Gravity pulls things.
In this context, I'm using the word pull, yes.
Okay. So does it pull helium balloons away? In the opposite?
It pulls the air around the helium balloon, which lifts them. Buoyancy contains the word gravity in its definition.
And is it that bends the horizontal?
You don't know what you're talking about. So gravity establishes a vertical.
Talking geometrically. And I can't see geometrically how you work your intersecting horizontals. It just doesn't work, Brenda.
Well, it
plain
does.
surveyors couldn't do their job if that was how it worked. They would have to have a whole new method. It doesn't happen like that.
They don't have
Brenda.
to have a whole new method. They don't. You can use flat Euclidean geometry on planet Earth because
What's that? Flat? No such thing, Brenda, as flat Euclidean geometry. You've just added flat in there for some reason. Why did you do that? Are you obsessed with that word?
Does Euclidean geometry include circles?
Yes.
Are circles flat?
It's axiom number 3.
Are circles flat?
If they're drawn on a plane.
Are circles flat?
Circles on a plane.
Are they flat?
On a plane. We're talking mathematically.
They're a circle, right? They're circular.
Get to that extra level.
Are curved lines flat, Bev? Are curved lines flat? Are curved lines flat?
Is that the mathematical description of flat?
Are curved lines flat?
Geometrical here. We're talking geometrical here, right, Brenda?
Are curved lines flat?
We're talking geometrically, Brenda?
I'm just asking a question. Are curved lines flat?
I'm asking you, are you talking geometrically when you are talking about this curved line?
What do you imagine I'm talking about when I say the word curved line?
I don't know.
You don't know what I'm talking about? You don't know what a curved line is?
Are you talking geometrically, Brenda?
What is a curved line?
What curve is it, Brenda?
What
curve, Brenda?
What's a curved line?
Curve?
What is a curved line?
Curve, Brenda? What sort of a curve, Brenda?
It doesn't matter. Any curved line. Are they flat? Is a curved line flat?
Is it on a plane?
Any curved line.
Is it on a plane?
It doesn't have to be. It can be anywhere. It could be
okay.
It could be.
I'm going to imagine a curved line on a plane. Okay, Brenda, and I'm going to tell you, it's a curved line on a plane.
Yeah, is it flat?
Decipher whatever you want.
Is it
Don't
flat?
bother asking me some stupid question containing a
flat?
stupid word.
Is it flat? Is it flat? You can't understand it, can you? Is a curved line?
Do you know what a plane is in mathematics?
Is it flat? Is a curved line flat?
Mathematics.
Is a curved line flat?
Do you know what a plane is? You not know what a plane is? Why are you asking me a silly question like that if you don't know what a plane is?
I know what a plane is.
You do know what a plane is.
In Euclidean geometry, can you have a curved line that is not
in
flat?
Mathematics?
Can you have
check in the chat, Brenda, for 1 second, right? I'm going to read out for you now.
I know what a plane is.
A plane is a flat, two-dimensional surface that extends infinitely far.
I understand that. I understand third grade math.
So this curve that I'm imagining is on a plane.
Can you have a curve that isn't flat in any plane? Like a spiral or just a random curve?
Like a sphere?
No, not a sphere.
The surface of a sphere.
Like a spiral.
That would be a curve that is not flat in any plane, wouldn't it?
Right, correct.
Okay, so you've just asked me,
and that's
can I imagine it?
Yes. Is that Euclidean geometry? Are spheres in Euclidean geometry?
Yes.
Well, there you go. There's the answer to the question.
Solid geometry.
Yeah, that's Euclidean, isn't it?
So yes, Euclidean solid geometry.
So when you were pretending,
you know that.
So when you were pretending not to understand a curved surface, how plumb lines could be point in different directions
no,
on
Brenda,
a curved
Brenda,
surface.
you've done
You
it
were
again.
pretending.
You've just done it again.
You were pretending not to understand.
Just confused a ball with a thing that you're stood on, haven't you? When is the moment you added plumb lines to the sphere that we were talking about in Euclidean geometry, you made a pretty big mistake there. Could you see it?
On a sphere with gravity.
Okay, spherical geometry. Then we're talking about.
Right. Then a plumb line.
Spherical geometry. Okay, no, you can't do a plumb line on a spherical geometry.
Yes, you can.
No, you can't. It's just spherical geometry is the geometry of a two-dimensional surface of a sphere. 2 dimensions doesn't have a vertical component to it. Sorry.
No, a solid sphere does. A solid sphere in 3 space does.
Yeah, but that wouldn't have a vertical that is an extended radius line, would it? Because that'd be fucking ridiculous.
That's
absolutely mental to imagine that you could put gravity on any sphere. Do you imagine that?
Gravity.
Do you imagine that? Is that an imagined?
Gravity is a force which pulls all objects to the center of the mass.
Of a sphere.
To the center of mass.
Right. So every sphere would do that then. Yeah.
On a planet, you'd have to be measurable. There's spheres where it would be too small to measure.
So spheres in reality then have a vertical and a horizontal, just like you do.
No, they don't.
Yeah, of course they do.
No, they don't.
Yeah. The top would be the vertical component, and then the horizontal would go from side to side, just like any graph in Cartesian coordinates.
So this is where you're pretending not to understand this. You're pretending to not understand.
I'm just living in reality and describing reality, Brenda.
No, you're pretending not to understand. You're a Poe. Everybody understands that. You're a Poe. You're pretending not to understand this.
What's that? Sorry, Brenda? What did you call me?
A Poe.
What's that?
Look it up.
No. You just called me. What is it?
Look it up.
I'm here explaining reality to you and to everybody else listening.
That's what you are. Is somebody who pretends to be something they're not.
What am I pretending to be then, Brenda?
You're pretending not to understand. You're pretending not to understand these things. Right?
You're saying I'm pretending to not understand it, but that
just like you pretended
pretending to be something that they're not.
You're pretending. So therefore,
just like you're pretending.
Right, because you're pretending.
Be it,
Bev. You're pretending, just like you pretended not to be able to imagine being on a sphere, and then when we brought it up later, all of a sudden you could imagine it.
It's amazing.
All of a sudden you could imagine being on a sphere. And before, for half an hour, you couldn't.
I told you. Of course you
couldn't
can.
understand.
You stand on top of a sphere. Yes. I can imagine anybody standing on top of a sphere.
But before you couldn't.
I can't imagine anybody standing on the bottom of a sphere. That's fucking ridiculous, isn't it?
No, it's not ridiculous. Why would that be ridiculous?
Yeah, it is.
Why would it be ridiculous? Why?
What, somebody standing on the bottom of a sphere?
Yeah, why is that ridiculous?
I've just got to go and help the missus make a brew. You explain to people how.
Yeah, run away. Go ahead and run away.
Run away to go to the cat.
Hey, Brenda, you're a guy who's pretending to be a girl. How dare you?
No, I'm not.
How dare you?
I'm not.
How dare you?
And you can show your bigotry and your prejudice. You can show your prejudice.
Not prejudice.
It's
insane.
Bigotry. It's bigotry and
You're
prejudice.
Insane. It's not bigotry. It's called chromosomes.
Yes, it is. No,
it's biology.
Yeah, you don't understand biology.
Bev a pretender. Don't
yes,
be calling Bev
I
a
can.
Pretender.
I can.
Don't be
because
calling
Bev
a pretender when
Bev
you're the
pretends.
Pretender.
I'm not pretending
you are
anything.
The pretender.
You can. Yes, that's just your bigotry and your prejudice.
You are the pretender.
Yes, I know. Your hyper religious bigotry and prejudice.
No, it's not a hyper religious.
Yes,
you're
you
a
are.
Guy who says you're a girl. That's a pretender.
That's fine. You can believe that.
No,
you're welcome to believe that.
Don't be accusing Bev
I can.
Being a pretender.
I can.
You're the master pretender.
I can.
Now that you shouldn't go down that road. That's not the road you should go down. You should
I
argue
can.
with facts. Now, what
I
is
am.
a concept, Brenda?
I
Let's
am.
go with a concept. What is a concept?
It's an idea.
What is it? Okay, so it's not reality.
Concepts are in your head. They're in your mind. Yes.
Right, and Bev is talking about reality.
Concepts describe reality, don't they?
When they go against reality, what do you call it?
How would you determine when your
they go against reality, what do you call it?
I would call that imagination.
That's what your concept is then. It's imagination.
You'd have to show that, though. You'd have to show that.
No, we have shown it. What is gravity? You keep saying it's a force, and people smarter than you tell us it's not a force.
It can be considered as a force, yes.
But it's not a force.
It can be considered one.
Anything reality. We're back to concepts.
No, that's not true.
Yes.
That's not how it works.
Yes, you live in the world of imaginations, and the one thing you should never do is call Bev a pretender. You're the biggest pretender.
No, Bev is, your moral outrage.
No, it's not moral outrage. Is that you don't throw rocks against glass houses when you live in the big one.
I don't live in a glass house. Mine is made of solid stone.
You're pretending to be something you're not.
Yeah, that's your moral. That's your moral outrage. That's your moral outrage.
No, that's not.
I don't care.
Outrage. That's a biological fact.
I don't care about your moral outrage.
That's a biological fact. I don't care.
No,
what
it's
you
not.
Want to believe
it actually
you
isn't.
Are, but don't
it actually
be calling
isn't.
someone else a pretender when you're the biggest pretender. Go somewhere else where you have some cowbell.
Yeah, Bev.
Okay, so what's
Bev
the
is a pretender. Bev pretends to not understand geometry.
Brenda, let me ask one question and then you can have the mic back. You called Bev a Poe before, and what was the reason for calling him a Poe? Because he said he couldn't imagine standing on a sphere, and then he could imagine all of a sudden, right?
I think Bev is a Poe because I'm getting feedback.
Sorry, that's me.
Okay, I called
Bev... You think Brenda's a Poe?
I think Bev is a Poe because of his constant equivocation and avoiding of addressing issues, and then suddenly at a later time in the conversation, he can understand those issues. That's why I call him a Poe.
So I'm just going to point out a hypocritical position that you're in now, and then I'm going to leave, and that's fine. You say that Bev's a Poe because he couldn't explain something, but then miraculously could later on.
Yeah.
So you know that gravity is not a force, and even though you can think of it as a force, that makes it conceptual only. But in the real world, it's an effect, and you push that it's a force anyway. I heard you repeat it many times. That makes you a Poe.
Gravity is a force. The fact that you don't understand this distinction, right, doesn't mean I don't understand it, right? Gravity can be conceived of as a force because it establishes a vector to objects, and anything that imparts acceleration to an object is a force.
Brenda, it doesn't establish a vector. It's an effect. The vector's already been established by... Brenda, the vector's already been established by something else, and gravity is the thing that now suddenly starts moving, but it's not being pushed by gravity. Gravity is the thing that's already being pushed by something else. An effect.
Can an effect...
You know this.
Can an effect be a cause?
If it was an effect that was a cause, it would be defined like that, but it's not. It's defined as an effect. That doesn't mean that it's an effect that could be a cause.
Can an effect be a cause?
Ordinarily, perhaps. In this context of gravity, no, because it's defined expressly as an effect.
What kind of crazy question is that? An effect and a cause are two different words. They have separate meanings. What are you trying to say?
I just wanted to point out that you're being a Poe, Brenda, that's all.
If I use a cue ball to I use a cue stick to set the cue ball in motion, my striking the cue ball is the effect. The cue stick is the cause. But that doesn't mean...
you holding the cue stick is the cause. If the cue stick is sitting on the table without you holding it, ain't going to push a cue ball. Are you insane?
Yeah, Brenda, in scientific method, the presumed cause, which would be the striking of the cue ball by the cue, is the thing that's manipulated by the researcher. So you've got to manipulate that cue to strike the ball, otherwise it's not the cause in scientific method.
Right.
But you can think of it as an effect if you want to, but that doesn't make it reality, that just makes it in your mind.
So if I cause the cue stick to move and to strike the cue ball, right? That's cause and effect.
That
right?
would be the cause, yes.
Right, you caused it.
Right. So I caused the cue stick to strike the cue ball and to set it in motion.
You caused it. You caused it.
So the motion. So the motion of the cue ball is the effect, right?
Correct.
Can the cue ball then strike another ball and set it in motion?
But that's not how gravity defines.
Then, in that case, the cue ball is the cause, and it's striking, say, the 6 ball is the effect.
Yeah, but that's not how gravity is defined, Brenda.
That's how it works.
Gravity is expressly defined as an effect. That doesn't mean it's a consequential cause. It's an effect, Brenda. It's the end of the line. It's the ball moving because something struck the cue ball, and it was you, because you picked up the cue, and you struck the cue ball, and the cue ball started to move. So gravity is the moving of the cue ball, and you need something to hit it or push it, but you haven't got anything on your model.
The point is,
it's like
the point
dominoes. You got secondary, tertiary causes, but the first cause, that's what we're looking for, Brenda, is the first cause. You ain't
we're not.
got it.
I'm not looking for the first cause. I'm just using a gravity
then
to
you
explain.
don't have an effect. Well, then you don't.
You
have
said
an
it. You
effect
said
if
gravity
don't
is
have
an
a cause.
effect.
Stop over talking me. You cannot have an effect without a cause. Would you agree with that?
You said.
Would
that
you agree with that?
Sure. I'll accept
that. So then you agree that cause precedes an effect.
Sure.
Okay. So if I set up a bunch of dominoes, and one's going to fall on the other, and on and on and on, then the second and third and fourth have an effect on the fifth. But who has to start it?
That's not what we're talking about here.
No, that's what you used as a silly example of a ball hitting another ball and hitting off the corner of a table. But we're looking for cause and effect, and you have not established that.
You said gravity is an effect, isn't it?
No, I didn't say that.
Well, Anthony said
it was. Warrior
was
taught. I am tearing apart your weak argument to Sleeping Warrior, saying to you that you're describing an effect with the word gravity. Now, gravity is what, according to someone smarter than you, named George Musser? What is it?
So I'm talking.
What is it?
What is what? It's the
what
bending
did George Musser say gravity
It's the
was?
bending of space-time.
No. What did he say it was? You can think of it as a force if you want to.
Yes.
But it's not. Hang on. Let's finish it. But it's not a force.
And what is the rest of it? The rest of it is that you can think of is that it is a force.
You caused it.
I caused what?
You pick up something and drop it. You're the cause of it. It's going back to equilibrium. This is so simple.
No, I'm not the cause.
Okay, let me ask you something. There's a rock in front of your house by the door. Wherever you live, there's a rock in front of your house by a door. It's been sitting there for 5 years undisturbed. You pick it up. What caused it?
What caused what?
Picking it up.
What caused what?
If you pick it up, if it moves, if it's been there undisturbed for, say, 5 years, and then you pick it up, what caused it to move?
I caused it to move by exerting a force.
Thank you very much.
But
that settles the case.
No, it doesn't. If I let it go.
Yes, it does.
If I let it
there at equilibrium.
No, it doesn't.
It's happy resting. It's resting. It's happy where it's at. It's not falling. It's not being pulled. It's not being pushed. It's just sitting there happy as a dog. And then you pick it up, you disturb it, and you let it go. And guess what? It's going to fall down right next to
letting it go
over the same spot.
Letting it go.
Over the same spot. Maybe.
Do I get to talk in this scenario or not?
Well, yeah. After you stop interrupting me in the middle of my sentence, maybe. Everything you said has to do with the imagination and concept.
No, can I speak now?
I'm not done. I will tell you when it's over. You said words. I listened. You kept saying to Bev, concept. We're looking for reality. Now, if you look up the word concept, it's a thought experiment. It's an imagination. It's something in your mind. We are looking for reality. And Bev was describing reality, and you called him a Poe. And that's when I got upset at you for calling him a Poe, for pretending to be something that you thought he wasn't when you're the one doing it.
Yeah, your moral outrage and bigotry and prejudice doesn't matter.
Listen, if you're going to go there, I'm done with you, because I don't care if you think you're a dog. I really don't. The point is, you are a pretender clown calling someone else who's in reality.
Your moral outrage doesn't matter. I don't care about your moral outrage.
Like I said, you can think you're a dog. I can care less.
I don't have
no word. Why do you keep interrupting me?
Well, when do I get to talk? When do I get to respond to your claims?
If you stop interrupting, you might get to talk.
Well, it's been 5 minutes. When do I get to talk?
Well, you've been interrupting for 5 minutes.
You don't really, Brenda.
No, but when do I get to talk? I want to respond to him.
Hang on. You get to talk. Bev is back. Bev, I hand it back
to you. No. You can carry on, 10th. I mean,
Well, I'm trying to tell Brenda that if she wants to pretend to be a dog, a tree, I can care less. It's not a moral outrage. The outrage I had, excuse me, I'm in the middle of trying to explain my outrage. Please don't
now it is moral outrage.
Don't interrupt my outrage as I'm trying to explain what the outrage is about. The outrage wasn't about you pretending, or what you think it was. Moral outrage, as you said, religiously. I can care less if you think you're a rock or a dog or a bird. That's up to you.
Well, you obviously do care.
No, I don't care.
You obviously do.
Will you stop interrupting? The reason I interjected at all was because you said Bev was pretending.
Yes.
That's when I objected.
Yes.
Now let me finish. I don't care if you want to think you're this or that or the other. That's between you and the Creator. I don't care. I don't lose any sleep over.
That's not true. You obviously do care.
I do not lose. Why are you constantly interrupting?
Because you're just constantly talking, and I'm waiting to answer, and you don't let me.
You misdiagnosed me. I'm trying to clear the air. My outrage is not what you think it is. So let me explain what it is. The hypocrisy of you saying that Bev was a Poe is why I entered in the conversation at all. That was my outrage. The biggest pretender of all. Okay, that's why I enter. Not because it's moral, not because it's religious. I can care less. You can
you're wrong.
You want. So please, no, quit. I'm trying to tell you why I entered the fray.
Well, you did.
You keep wanting.
Do I get to talk yet?
Oh my goodness! I'm trying to state that your description of my outrage is wrong. Will you let me finish?
I understood it 10 minutes ago.
No, you didn't. You've been repeating it as a moral, religious outrage, and you're wrong.
Yes, it is.
No, you're wrong. Not. So how could you understand it when I'm telling you you're wrong?
You think I'm hypocritical. You think I'm hypocritical because you don't think it's legitimate for somebody to say that they're transgender. You don't think that's legitimate. No. That's not based on reality. That's based on your religious belief.
No. Listen,
misunderstanding, Brenda.
Listen, please. I have a family member who is transgender. I know a lot.
I feel sorry for her.
Yeah. Well, listen. I know this topic quite well. I've done my hours and hours.
I would like you to tell your friend. I'd like you to tell your friend. Well, you never let me talk.
Why are you interrupting?
Because you never let me talk.
No, you won't let me finish a sentence before I'm done, and you want to talk? Are you nuts? I'm done with you, Brenda. You're insane. Bev, take over.
Yeah. Good riddance.
I don't know what you think you're going to be ending up saying here, Brenda, because you've not really got much to say.
Yeah, I'm going to complete what we were talking about, which was the claim.
No, what were we talking about?
Do I get to talk or not? Do I get to talk or not?
No, because I don't know what you're talking about.
Do I get to talk or not?
Not really, no.
Well, you came into the middle of it. You came into the middle of it. You don't know what it's about.
No, Brenda.
So be quiet.
Brenda, you came into this server.
No, you came in. You came in just now.
I was here
you were
before.
gone. You were gone, and now you came in.
What
you
were
don't
you
know
talking
the discussion.
about?
You don't know. You don't know, do you? So shut up, sit
I'm
down, and
asking
zip your
you
mouth.
What
Zip it. Zip
is
it.
you are saying.
Zip it. Zip it.
Brenda. Who are you talking to?
So I want to complete what I was talking about, which is that.
What were you talking about? I was saying recap, please.
We were
It's been a
talking.
while, hasn't it?
We were talking about gravity and whether it can be a cause or an effect. An effect.
Yeah, it can't be. It's only an effect.
No, that's not true. Then a billiard ball can't impact another billiard ball, which can impact another billiard ball.
Okay, so Brenda, Bev, just give me 1 sec. So when you finished with the billiard balls hitting billiard balls and you get to the final billiard ball and the final billiard ball then moves, that last moving billiard ball would be the effect. All the other ones prior would be all primary, secondary causes, right?
No,
but gravity's not.
No.
Yeah, it would.
No,
So where
it's a
would the
chain.
effect be?
It's a chain of cause and effect. Every billiard ball
but
causes
here's the thing, though, Brenda.
is an effect
Brenda,
and
the
a
thing
cause.
is-
Things can be an
No,
effect
it's not.
and a cause. Yes, they can.
So if you hit billiard ball 1 with your cube, the cause is you hitting the billiard ball with your cube. If that ball then hits another ball, the cause of hitting the other ball is the first billiard ball that you've already hit.
No, it's not. No. The
What
cause
is it then?
The cause is the first billiard ball hitting the second one.
That's what I said.
And the third billiard ball hitting the fourth one. The cause is the
Now,
cause is
are any of
the
them-
cause is the
are any of
third
them
billiard
effects,
ball.
Brenda?
They're simultaneously cause and effect.
No, they're not. Cause is something.
Yes, they are.
No,
You
Brenda,
can have a
it's not
causal
effect.
chain. It's called a causal
Brenda.
chain. It's a chain
causal
of cause
chain.
and
Causal.
effect.
Brenda, the key word is the causal chain, right? We don't have an effectal chain, do we? It's either causal chain or it's an effect.
No, each billiard ball becomes simultaneously the cause of succeeding events and the effect of preceding events.
No, because all the causes of all the previous billiard balls, all hitting all the other billiard balls, they are all causes, right? And
No,
the
they're
effect
causes
is only
and effects.
So, Brenda, listen. When billiard ball 1 hits billiard ball 2, the cause of hitting billiard ball 2 is the first ball, right? And when 2 hits 3, the cause of 3 moving is 2's hit it. And then same for 4, 3's hit it.
Right.
And 5,
You got
4's
it.
hit it. Right.
Yeah, that's a
Yeah.
causal
But the
chain.
problem
It's a cause of each cause becomes
Brenda.
and affects a change in a subsequent ball, which then becomes the
problem is, Brenda-
cause of additional effects.
But Brenda, listen, the problem is the definition of gravity. The definition of gravity describes gravity as the effect. So it's not part of a causal chain, it's the result of the causal chain.
No, it can be gravity can cause other. It can be an effect and then
It can't.
cause.
It's an effect.
No,
it can't. Otherwise, it would be a cause.
It can do both.
It can't. Otherwise, it would be considered a cause and effect, and it's not. It's considered an effect, and that's the last one.
An effect can be a cause.
It can't. An effect is the result. So, the effect of catching a cold is coughs and sneezes, but coughs and sneezes are not the cause. They're the effect. That would be gravity.
If
the coughs and sneezes being spread through sneezes and whatever, that's the cause of spreading it. That would be not gravity.
If billiard ball 3 is moving, the cause is billiard ball 2, right?
Correct.
Then billiard ball 3 causes billiard ball 4 to move. So billiard ball 3 is both an effect and a cause.
So where's the gravity in it then? Because there is no. You have to identify the effect.
So gravity can be both a cause and an effect.
No, you have to identify the effect. So if billiard ball 2 it's 3, 3 it's 4, and 4 it's 5, please identify the effect.
It depends. So if I'm in the middle of that chain, the cause of billiard ball 3 moving is billiard ball 2. The cause
Correct.
of billiard ball 4 moving is billiard ball 3. So billiard ball 3
I asked you to
can be
identify
both
the
a
effect.
cause and an effect.
No, because the minute you say it's an effect, that's the end of the chain, Brenda. Otherwise,
No.
it's still a cause.
It's not the
Yeah.
end of a chain.
It is, because you need to identify where the effect is, and there's only one place the effect is, Brenda, and it's at the end.
No, that's not true.
Okay, so if ball 1 hits ball 2 and ball 2 hits ball 3, where is the effect? Tell me the effect.
It's in the middle.
No, go on then, quantify it. Where is it?
So ball 2 hits ball 3. That causes
Right.
ball 3 to move, which causes
Right.
it
So there's
to
no
strike
effect there,
ball
though, is there?
4. It
No,
depends
ball 4's
on your
not in it. Ball 4's
Yes.
not in it.
ball
No,
3.
there's no ball 4.
Ball 3 is affected by ball 2, but it causes
No, it's
ball 4.
affected. It's no. Ball 3 is affected, not effected. Affected. So ball 3 is affected by ball 2, but that doesn't make it the effect. It's affected by something else. You're correct, but it's not the effect. There's only one effect, and it's the end of the chain. Everything else is causal, and you can say they're effects if you want to, provided that's the end of the chain. But if it's not the end of the chain, Brenda, the effect becomes the end of the chain at the end. That's why gravity is an effect, and it's not a cause.
That's just nonsense. A causal chain.
No, you don't understand
is a
cause and
chain-
effect.
A causal chain. You're
Brenda,
just,
you don't understand cause and... Right, Brenda, let's change it so it's slightly different.
You're just
Let's-
using words to try to define things. But cause
Yeah, that's
in a
what happens
causal
with-
change, in a
Definitions,
causal
though,
chain,
Brenda.
in a causal chain, each cause can become a subsequent effect, which then becomes a cause of further effects. It's cause and effect, cause and effect, cause and effect.
Yeah, but what you're trying to do is say that there are 3 or 4 different effects in the middle of the chain. No,
Yes.
the effect is the end of the chain. Otherwise, it wouldn't be the effect.
But
It
there
would be a
is no-
cause of something else.
But there is no end of the chain.
Yeah, there
Time-
is. There's only
No,
a finite
no,
number
there
of
isn't.
balls. Yeah, there's not a ball 5. We said there wasn't a
No.
ball 5.
Time keeps on moving. Time is always moving. So there's a continuous amount of change in the world. Everything is always
Yeah, but
changing.
there's only 4
So
balls.
there's no
There's only
end.
4 balls here, Brenda. There's not a 5th. So we know that we can identify where the causes are, and we can say which one's the effect. Now, if you're going to say that the effect is between 2 and 3, and the effect is ball 2 moves because it's hit by ball 1, but it hits ball 3 and it starts somewhere else, I'm going to say no, that's another cause.
You're just wrong, and you're just trying to define reality by using words. So
Then you don't understand cause and effect relationships. It's that, and that explains an
I
awful
do.
lot.
I do understand
don't-
them.
Brenda, if you've got 4 balls but you haven't got a 5th ball, the only effect would be the end of the chain, because everything else is a previous cause. Otherwise, there would be no end. It would be continuous.
That's how the world works. The world.
No, but there's only 4 balls. There's not a 5th ball, so
But
there
that-
is an end.
No, it doesn't end. It just keeps on moving forever, right?
There's only 4. Right. So if it keeps on moving forever but doesn't hit another ball, that
It could,
movement
though.
forever. Hey, listen, Brenda. If it keeps moving but doesn't hit another ball, that movement forever would be gravity. That continuous movement forever, because that's the effect.
No, so it could move in a straight line. You accept Newton's basic laws. It would move in a straight line forever. It could move for a
So
million years.
now you're moving away from the point. Now you're moving away because you don't want to concede. If that last ball doesn't hit anything else, that then becomes the effect. The moment it hits something else, that moment, that interaction, that then becomes what was previously an effect, is now the cause of the new thing that's happened. And that's all it is.
Right. So you're admitting that it never ends. The causal chain never ends.
No,
Yes,
I'm saying
yes,
that there
you
is an
are.
end, and that end is the effect.
But there is no ending to it because everything.
Yeah, there
moves.
is. So when Newton's apple falls from the tree, right, and you guys say gravity pulls it, right, and we know gravity is defined and we know what causes it, we know that it's not being pulled by anything because we know gravity is defined as an effect, and it's the effect caused by uneven distribution of mass. That's what Einstein says.
If gravity is an effect, it can't cause anything to move, can it?
Correct. So what makes the apple move?
Gravity.
But you just said it can't make the apple move.
Well, according to you. But
no,
it does.
According to Einstein, the current position in physics.
No, you don't understand physics. You don't understand elementary math.
Don't like Brenda. You said you don't understand too many times.
You don't.
You don't. Emma's not even in this room because you're in here. Just keep obfuscating the point all the time.
The point is that gravity causes objects to move.
It doesn't, Brenda. It can't cause objects to move. It's an effect.
But they move. Therefore, it does.
So what causes them to move? A push or a pull. But it ain't gravity doing it, because gravity is the effect of it moving. In other words, the apple's falling.
Then what causes them to move?
That's what we're asking. That's our question. You're supposed to know all the answers, though, right?
It's gravity.
It isn't. Gravity is the effect.
If something falls, Brenda, it's because I've picked it up and dropped it.
You didn't. No, that's
the cause was me actually dropping it.
No, it isn't.
Yeah, if I don't let go, Brenda, it doesn't fall.
But if you let go, you're not causing the rock to fall.
My hand releasing it is the cause.
That doesn't cause things. That doesn't cause things to move.
Brenda, your problem is if he picks it up and lets go of it and it starts to fall, and now let's remember that helium balloons fall to the clouds, right? Whichever way it falls, when it's in movement, that movement, by definition, according to Einstein, your current physics, that movement is the effect of gravity, right? The movement. But you need a force to make it move, because Newton's first law, and listen, Newton's first and second law require a moving, accelerating object to be pushed or pulled, because that's the F equals ma. So what force is doing it?
The force of gravity.
No, it's an effect, Brenda.
Yeah, but it can be considered
cause and effect.
But it can be considered to be a force.
Only in your head.
No, in reality, it can be treated as a force.
If it's Brenda. If it's an effect, it's the end of the chain, right?
So then it can't cause. So then it can't cause things to move, can it?
Correct. So what makes the apple move? We're back to square one.
Gravity does.
It can't make things move.
Yeah, but nevertheless it does, right?
But it can't. You can't make something that can't do something.
Yeah, so there's a problem here, and the problem...
Yeah, you're right. You're right.
Yes.
Welcome to Flat Earth, Brenda.
Yeah,
there is a problem. Welcome to Flat Earth.
Right. No, but the problem is your arbitrary definition and declaration that gravity can't cause anything to move.
But Brenda, it's not my definition, it's Einstein's.
It's not. You don't understand Einsteinian gravity at all.
Can you define Einsteinian gravity for us so that we know that you at least know the definition?
So it's the bending of space-time.
No. Try again.
What is it then?
No, that's not the definition. Do it again.
No, tell me. I don't know then.
It's the effect of the curvature of space-time caused by the uneven distribution of mass.
Yeah, and causes can have further effects, can't they?
Yeah, bending space-time. So how did the apple move?
Because the effect of gravity caused the apple to move. Just like the third billiard ball.
Gravity can't cause the apple to move, Brenda. It's an effect. You don't understand cause and effect. When you said before, Brenda, when you said before that we have a problem here with the definition, right? You attributed it to me, and I said, no, it's Einstein's. You're right. We do have a problem, and it is the definition. You're absolutely right. It's not my definition. It's Einstein's. But you know what? It fucks your model, because you can't make apples move with an effect, because the apple moving is the effect, but you need something to push it according to Newton's first and second law. So what is it that pushes it or pulls it?
Gravity does, because effects can be causes. As you demonstrated with the billiard balls, you admitted that effects can be a cause.
Brenda, the minute an effect becomes a cause, it's no longer an effect, and we know gravity is the effect of the curvature of space-time. So what makes the apple move?
The gravity does, because gravity...
No, it can't do that. It's an effect.
Why not? Why not?
Because Einstein defined it, and it fucks your model. It's not my problem you don't like it, but you need to make it a force. But it's not. It's defined as an effect, Brenda. Welcome to Flat Earth.
So if the movement of billiard ball 3 hits... the movement of billiard ball 3 is an effect of it being impacted by billiard ball 2. According to you, then billiard ball 3 cannot cause billiard ball 4 to move.
No. The minute billiard ball 4 is introduced, and if number 3 hits it, that then becomes what was previously an effect, then becomes a cause. But remember, we haven't got a 5th billiard ball. We're stopped at 4.
Yes, we do.
So if billiard ball, no, we don't. We've stopped it at 4 because there's a finite number of balls, and we're not going on forever. We're not having an infinite regress.
There's an addition. We have an additional mass in the gravitational effect. That additional mass then becomes the effect of gravity.
Yeah. So it's moving. So what's caused it? Was it the previous billiard ball, or was it something else?
Gravity caused it to move.
No, gravity's the effect, Brenda. So if we haven't got a 5th ball and we've only got a 4th ball, and let's say it had perpetual motion and Newton's first law applied on Earth, that it could continue on without, it would carry on in a constant direction at a constant velocity unless acted upon by a force, right? Let's just say it carried on forever. That would be the effect of gravity, the continuing movement of that ball, because it hasn't got another ball to hit, right? That's the effect of gravity. But it's moving, and it was hit by a previous ball. That previous contact with the previous ball is the cause. Otherwise, it wouldn't be moving, because you need a force to make something move. But when that object's moving, and there's not another ball for it to hit, right, that then becomes the effect. And that's the definition. But you need a force to make something happen. So what makes the apple move?
But effects can become causes, and gravity is an effect, and it can become a cause.
Right, but then there's no effect, so you need to identify the effect.
Well, the effect would be the object moving.
Right, that's the effect, right? So there would be the gravity, right? But what makes the apple move?
The gravity did. The gravity became the cause
the gravity's
of it
the apple moving. The apple's gravity's the apple moving, Brenda.
The gravity is the apple moving? That's not gravity. Gravity is an effect.
That's the definition.
Gravity is an effect.
Oh,
How can
Tony?
That's right. So the apple moving is the effect. But what made the apple move, Brenda?
The cause was gravity. Gravity became the cause
no, it wasn't.
of the apple moving.
Gravity's an effect. Brenda, gravity can't do that. It's an effect.
Effects can become causes.
But then they're not effects anymore. But we know gravity is the effect. So it has to be the movement is the gravity. But what makes it move?
If billiard ball 3 becomes the cause of billiard ball 4 moving, it doesn't cease to exist because it's now a cause instead of an effect.
I didn't say it did. That's a straw man. If billiard ball 3 hits billiard ball 4 and 4 starts moving, that movement is gravity according to the definition by Einstein. Not my definition, Einstein's definition. However, we have the effect, but we have a ball that hits it. But when the apple falls from the tree, Brenda, we haven't got anything contacting it. It moves all by itself, but no forces, because the effect of gravity is it moving.
It moves because gravity is causing it to move.
No, it's not. It's an effect.
Because
gravity's an effect, Brenda.
Effects can be causes.
Gravity is an effect. It can't cause the apple to move. It's the effect.
Effects can cause things.
But then it's not an effect anymore, and we know gravity is the effect by definition.
That's not true.
So if billiard ball 2 hits 3 and 3 starts moving, but there was a billiard ball that hit it, we know that billiard ball 2 was the cause. But you can't have billiard ball 3 start moving when nothing's hit it, because you need a contact, don't you? You need a force to push it or pull. So we have the apple falling from the tree for some magical reason, and we know by definition the effect of the curvature of space-time caused by the uneven distribution of mass is gravity. So we know that the apple's moving, and the effect of gravity is the acceleration of the apple, but something's got to make it move. You need a force, and you can't have a force and an effect because then you haven't got an effect. So we know the effect is gravity. We see the apple move. What makes it move?
Effects can become causes, as you said.
But then they're not effects.
Brenda,
then they're not effects anymore.
Yes,
Brenda,
they are.
They're not effects anymore. If
they can be simultaneously caused.
The end of the chain.
They can be simultaneously considered to be cause and effect.
Brenda, you're conflating. Brenda, you're conflating cause and effect because you need to do that for your model. But yeah, you are.
It's just
everybody can see it, Brenda.
It's just a point of view. It's just a point of view.
No, it's definitions, and words have got meanings, and Einstein defines them for us to stop idiots like you telling us that forces can be effects. They can't. They're different.
Why can't they?
Because they're different. You can't make the apple move without a force. So you need a force, and we know the effect is gravity by definition of Einstein. So what makes the apple move? Don't say gravity.
Gravity does, because
it's an effect.
Effects can
Brenda,
be causes.
Stop conflating the term.
An effect can be a cause.
Brenda, Brenda, if I asked a 5-year-old what makes the apple fall from a tree, 9 times out of 10 he's going to say it gets too big for the stalk and the stalk snaps. Why is that not the answer?
Because we don't think in terms of 5-year-olds. And a 5-year-old would understand that gravity makes the apple fall. That's what a 5-year-old would understand.
No, gravity doesn't know. Yeah, right. A 5-year-old will think that because he gets indoctrinated by teachers that have been told that Einstein says that gravity is an effect.
That's true.
But in the national curriculum, they have to teach that, right? That don't make it true. Einstein's your current citation, and gravity is the apple falling. But we know that you need a force to make it fall, right? And we can explain it with relative density, but you can't explain it without gravity being a force. And it's not a force, is it? It's an effect. So you're fucked, Brenda. You just don't like it.
You can't explain it with specific gravity. That doesn't explain why things.
I didn't say specific gravity.
You said relative density. Relative density is specific gravity.
No, I said relative density disequilibrium. It's a new term that doesn't previously exist.
No, it means specific gravity. That's what it means.
No, that's what you think it means, but that's not what I say it means.
That's the
and it doesn't matter what I say. The point is, Brenda, I can explain it. Brenda, I can explain it with relative density disequilibrium. You can't explain it without force.
You can't explain it because
it's just more dense than its medium.
Density isn't a force.
You're right. You're right. It's a scalar. I never said density. I said relative density disequilibrium specific.
Well, looks like I got booted.